Okay, if not, I'm going to begin already. So, I'm going to start by saying I got a little bit of anxiety. Okay, so I will try to compose myself a little bit. And yeah, let's begin. So, hi everyone, welcome to our September holiday revision for Sec 3 E-Math. Okay, so I am Mr. Qian Wei. Okay, I think you all should already know who I am already lah. If you all, when you all sign up, you all should know who I am. Can I just check, right? Who have I met during the distribution day? You saw me, right? You recognize me? Okay. Anyone else? I don't recognize a lot of people. So I'm very sure got some other people one, but maybe they're online lah. Okay. So just a quick introduction on myself. Okay. The door is closed. Okay. I teach the entirety of secondary school math. Okay. So lower sec and upper sec. In case you all don't know, right? I just ended 2 lower sec classes. Okay, from 3 p.m. until now, non-stop. So this is my last class. Yay. Okay, so I teach, so my earlier classes were Sec 1 and Sec 2s. Okay, I also teach upper Sec. Okay, but this year I only teach A math lah. I don't teach E math. Okay, some background that y'all might want to know about me, or maybe you don't want to know. Okay, I took history math before, but I took that subject and I flunked it. So on the transcript, there's a U grade there. Okay, I'm very proud of it. But of course, having said that, I went on to do a degree in a bachelor's in mathematical sciences lah, and I got a distinction. So it doesn't mean you screw up history math means you won't do well lah. Okay. This is because history math is essentially just uni math. Okay, and I think something else you all might want to know about me is that I play games also. Okay, so I really play Minecraft a lot lah. Okay, and I climb mountains last time. Secondary school days I climbed Nepal, Annapurna, and Kinabalu. Okay, in Sabah. Okay, I'm not sure if anyone over here climbs mountain. Okay, I cook a lot at home. Okay, and I like Miffy. So if you all cannot see, I have a Miffy bag with a Miffy toy, and I think I have a Miffy bottle, but it's not here lah. Okay. Yes, somebody like Miffy? Who ah? Okay, don't try, don't try. Okay, I also sing karaoke lah, but sometimes when I sing already next day I will have sore throat lah. Then after that viral infection. Okay, I don't know why. Now some other things I do right is I will sometimes go and find random things and solve like random math problems that I used to do lah, and then I'll go and solve on my own. You must be thinking why this teacher a bit short, right? Okay, cause I have nothing to do. That's why I do these kind of things. Okay, but no lah, I have work to do as well lah. Okay, so yes, this is one of the math memes that I watch that I share lah. Okay, sine 0 over cos 0 is what? Tan 0 lah. Ha ha ha. Okay, now back to serious stuff. Okay, so overmark, right? We have expanded quite fast. Okay, and for those who don't know, I actually joined this year only. Okay, I graduated last year. So this is my first year teaching. But of course, I've done private tuition outside lah. Okay. These are some of our results. I think one thing I will use to summarize this experience, right, is that I think the tutors over here, we strive to give a positive experience to the students over here. Okay, and we do our best to make sure that more than just academics lah. At least for me personally, I try to ensure that my students are well taken care of lah, to the best of my ability. I think some of my students here can testify for that, right? No, oh, so sad. Okay, some resources that you will get, right, will be, let's say, okay, this one later lah, not very important. Okay, so I want to move on to our content first. Okay, today we'll be going through a few topics, but I won't go through everything. Okay, I will go through what I think is the most important one. Okay, so let's take out the booklet. Okay, if anybody else still got issues, please let me know. I already flashed the screen long enough already. Okay, so let's take out the booklet. Okay, and go to the first page first. Now, one thing to share, okay, is that I may not know everybody's name. I may not remember everyone's name. I try my best. Okay, roughly I know who is who lah. Okay. But today my main goal, right, I think I also want to check, right, who here, right, every topic is CMI one. Anybody, every topic is CMI one. Like you don't know anything one. Oh, serious ah? Okay, can. No, don't be shy, don't be shy. Okay, anyone else? Yes, okay, steady. Wow, thanks for being honest. Okay, The rest, anyone? Okay. How many of you think you are like 5 out of 10 confident kind one? Okay, maybe I think everyone is not so confident lah. So I won't name drop already lah. Oh, but today's goal, right, is I hope that I can teach and deliver this lesson as the best of my ability, right? Okay, so that at least you guys walk away with something. Okay, so we're gonna start with today's lesson. We will have 3 goals. Congruency and similarity. I think this is like everyone's weakness, right? Everybody hate congruency and similarity, right? I see a few heads nodding, right? Okay, there's menstruation, which I will just roughly go through, and there's graphs also. So every question I will ask y'all who don't like this topic or who is shit at this topic, that kind of stuff lah. Oh. Okay, so let's take a look at the first one, trigonometry. Okay, now I'm going to ask in this progressive manner. Who here Sec 2 trigo cannot make it one? You don't need to raise your hand, but just be alert. Okay, Sec 2 trigo is the part on the right, on the left, sorry. Okay, and what is the acronym that we use to remember our this one? Tuakaso, right? Yes, thank you. Wow, my first prank club. Okay, Tuakaso, I don't know if anyone told you the Chinese meaning of this thing. Anybody knows not? Big leg auntie, wow, very good. Yes, okay, because Hokkien, right, it's called Tuakaso. Okay, so big leg auntie, yes. Your teacher teach you one, right? Okay. So for the friends who don't know about this, right, Tuakaso is called big leg auntie. Ha 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 ha. Okay, but when will you ever be able to use Tuakaso? Right angle, yes. Okay, so you will only be able to use Tuakaso in right angle triangle. Okay, if you use this for any other type of triangle, cannot. Okay, can Okay, so for the tangent, okay, for right angle triangle, right, usually it's together with Pythagoras theorem, right? So what I normally tell you to do is to ask yourself, if you want to use Pythagoras theorem, right, the formula is a squared plus b squared equal to c squared, which means you need what? You need 1 side, 2 sides, 3 sides. Do you need angle for this or not? Don't need. Okay, very good. Thank you. I see your head shaking. So basically, you only need 3 sides. And you need to ensure that this is a right angle triangle. Okay? Those online, y'all can hear me, right? Got people PM me. Sorry. Can you have the PDF version? Can I double check everybody got the PDF version? I just now got flash, right? Y'all have or not? Okay, if y'all don't have, please let me know again. I will stop and give it to y'all, but please let me know. I will let y'all scan again. Okay? Now, for the other one, right, your trig ratio, right? Okay? This one you ask yourself, you need to have 2 sides and 1 angle. Okay? So tangent, okay, so usually 1 angle and 2 sides. Okay? Usually you'll be asked to find one lah. You will know the other 2, you'll be asked to find the last one. Okay? So like finding treasure like that. Okay? For right angle triangle, always ask yourself, the guy opposite the right angle is your hypotenuse. Okay? And then your adjacent, right, is called adjacent because it's beside. Okay? It's beside the angle. That's why it's called adjacent. Then opposite is called opposite because it's opposite the angle. Right? Make sense, Okay, so this is your basic Sec 2 stuff. Now, for obtuse angle, okay, for Sec 3 E math, okay, those who don't take A math one, right, y'all will only learn until like that. Those who take A math, right, y'all should know there's this thing called ASTC, right? So for the A math kids, right, y'all can actually just use you want to double check, you can use your addition formula lah. But for those E math kids, okay, you need to know that when you take the supplementary angles, okay, it's always 180 minus theta, right? That is your supplementary. So this is the acute, this is your obtuse. Okay, you know why I call acute, right? Because very cute. That's why very small size. Okay, so obtuse angle, right? If you have the obtuse angle of the sine or cosine or tangent of obtuse angle, right? You will have plus, minus, minus. So as you can see inside the signs over here. Now, how do you remember whether it's plus, minus, minus? Okay, if I show you the calculator, okay, you can see, right? Calculator, can you see sine, cosine, tangent? Who's the first person inside this tree? Who comes first? Sine, right? So sine is number 1, confirm plus. The other two losers, right? Minus. Okay, like that can already. Okay, so easy way to remember. Then some examples are, okay, the sine of 150 is sine of 30 lah. Okay, you just need to apply the obtuse formula to get 30 degrees, right? Then for the cosine of 40, you apply the obtuse, you will have a negative. Okay, same thing for tangent 60. Okay, can I my mic roll? Okay, okay, don't scared, don't scared. Okay, now let's move on to the next page. Okay, before that, anyone got any questions? No, Okay, this page over here, what I need you all to do, okay, is this one involves your formula, okay, and it's in your formula sheet. Okay, so I will quickly just show you all one of the school papers, right? Okay, Set 1 also have the same formula one. Okay, so I will just quickly show you all. Oh, there's no formula sheet. Haha, never mind. Okay, then never mind then. Let's go back to where we come from. Hey, no. No. Why so laggy? Okay, now I need to take a look at this. Okay, I want you to focus on the triangle over here. Okay, now we have the sides A, B, C, right? Okay, the angles the lettering, right, is always opposite to the side. So if your side is small letter A, your angle opposite it will be capital letter A. Can? Okay, then same for B and C. B, if the side is B, your angle will be capital B. Then if your side is C, your angle will be capital C. Can? Okay, okay, now let's run through the formulas that you guys need to know. So the first formula, right, in a traditional right angle triangle, right, you all know half times base times height. But sometimes you all may not know what are the areas that you all can use. Or rather you all don't know whether it's a right angle, right? In that case, you can apply the new formula. Okay, area of triangle is half AB sine C. Okay, this is in the formula sheet half AB sine C. Okay, it's in formula. This C, right, is supposed to be what? How is C related to the side A and B? Anyone? Is or what we call sandwich, right? S stands for sandwich. Okay, so it's in between but I'll be very honest this doesn't apply to sine rule. So you just remember that the C is in between A and B okay? Now for the sine rule, right, you just need to remember, okay, that you take the sine of an angle, right, over its opposite side will be equal to another of its angle, the sine of another angle, right, and its opposite side. So for example, if I take sine of C over C, right, which is this side, right, it will be the same as sine of angle B over the length that's opposite it. This is very clear cut to use one. I think no brainer. Okay. Then last but not least, cosine rule. Okay. Now you all notice if I cover this guy up, what do I have? Yes, this cosine rule is an upgrade of the Pythagoras theorem. Okay. So you will use the cosine rule if your angle is your triangle is once again not a right angle triangle. So all this sine rule, cosine rule, and half AB sine C thing is for non-right angle triangle. Okay, so that is the difference between the previous page and this page. Okay, so how do you use this formula? So once again, your A and your B, right, are two of the sides. Okay, your C is the last side. This angle is always opposite your so-called hypotenuse. So-called it's not the hypotenuse but so-called. Okay. Then sometimes they will ask you to find the angle, right? So you need to rearrange it into this formula. Now you don't have to. All you have to do is to simplify this expression on top. Okay, simplify, right? Then make cosine ACB the subject. Okay, you can always simplify first. Okay, I will show you in the examples later. Can? Okay, at this point of time, anyone got any questions? Oh, before that, let me charge my computer first. Later die. Then I'll have another set of headache. All right. No, it's not charging. Yes, it's charging. Amen. Okay. You need to copy down anything? Okay, anyone need to take down anything? This part. Okay, can. I give you a while first, Okay, 15 seconds. I think okay, right? Okay, can move on, Online guys, okay, Hey, y'all got any issues, just let me know, okay? I will try to accommodate, but I may not do it very well, Okay, now, let's look at some of its application. So this one over here is angle of elevation and depression. Now, what does elevation and depression means? Very simple, okay? You just imagine Miffy standing over there, okay? Then look up. Look up means you depress or you elevate. Elevate, right? Okay, because you look up, you elevate, you go up, right? So, you look up. This angle over here is your angle of elevation. But then if you look down, what happen? When will you look down? When you're sad, right? So my girlfriend always tell me, last time, right, when I together with her, right, she will tell me, hey, why you keep looking down, She say, you not happy, is it? I tell her, yeah, not happy, sad. Okay, so that's why this is angle of depression. Okay, I think it makes sense, okay, but it's true, when I'm very sad, I really look down one. It's true. Okay, and that one is quite extreme already. When I look down, I don't talk to anyone, that kind is very extreme already. So the thing is, they will say angle of depression or elevation from of A from B. That means when they say from B, right, your starting point is B. Okay, where you look at or where you're aiming towards is your A. Okay, this makes sense to you? Okay, you okay? Zoom in, okay, can see? Okay, can. So this is your depression and your elevation. Okay, I will hold this for another 30 seconds. I let you take down first. Now okay, Can. You want to take photo to can, you know that, right? If it's faster for you guys lah. Okay, can, I can move on, All right, let's move on. Brother, what's your name again? Isaiah. Okay, can. Isaiah, okay, Can, sick. Okay, now the next one, right? Okay, bearings. So bearings, right, is measured in degrees, right? It's your standard 0 to 360. However, bearings is like your log code okay? Always got 3-digit one. Okay? So even if the degree is 1, it will be bearings of 001. Okay? So for example, okay, 1 degrees in bearings is 001. Okay? And then bearings, right? Please take note. Is it in anti-clockwise or clockwise direction? Clockwise, right? You follow your watch. Okay, your watch go this way, your compass also go the same way. Okay, think of it that way Okay, and when we want to measure bearings, okay, it's always with reference to what? Where is my start? North, right? Okay, so my north is my start. Hey, thank you. Aria, right? Oh, who was it? I know you know. I will try to remember. Okay, so this one is your north, right? You go down this way, right? 60 degrees, right? Your bearings is 060. Okay? Then the other one over here, you need to measure from here. You go all the way down. That will be your 250. Can? Okay. Now, same thing, bearings of B from A means your outside point, right, is your B. Your center point is your A. So when they say from A, right, your north is always from A. Okay? So you start from A, you grow the north already, right? Then you wipe the thing down. Okay? Now, the last one over here, right, is your due north, due east, due south, due west, right? Okay? So some of y'all may be confused about the directions and stuff like that. Okay? Let me give you all an acronym. Okay? I'm going to draw this thing over here. What do you think I'm going to draw? Anyone? What is this? Hey, my drawing so bad, Elephant, right? Hey, thank you. Okay, so this is an elephant, right? And what is the elephant doing? spray water. Okay, so this elephant is naughty, right? So we call this naughty elephant splash water. Okay, can take this down. Okay, at this point of time, I think that's all for Trigo. Anyone got any other questions? Okay, and okay, last thing, right? Last thing over here, okay. It's not in the notes, but I'll just share with you guys. Now, there's one more concept that's tested also. Shortest distance. Okay, shortest distance. So for shortest distance, right, you always aim, let's say you are looking over here. Let me zoom in a bit. Okay, you're looking over here, right? You're looking along a line, right? Okay, your arc of view maybe is around here. Your shortest distance is always when you stare at the thing directly. Okay, and that direction that you look at is always the right angle to it. So you want to establish this already, right? You can use your Tuakaso to make use to go and solve for your relevant parts really. Okay? So this part, don't worry too much. We go through some examples, then you will see how it applies. Okay? Okay. Now, okay, can okay, let's move on to the next page. Okay, I will quickly run through this example over here. Okay, just quickly one. Now, okay, A, B, C, D are 4 points on a horizontal ground. Okay, for this type of question, please take note of what is being said inside this question. Okay, horizontal ground means these 4 points are flat. Okay, flat. Okay, they tell you that AB is 70, BC is 55, CA is 60, AD is 50, and then ADC is ACD is 50, and then ADC is a cube. Okay, just check. 70 have, 55 have, CA 60 have, AD 50 have. Okay, ACD is 50, and ADC is acute. Okay, ADC is acute means this is acute lah. Okay, acute means is what angle? Sorry? Small is less than? Very good, very good. Okay, less than 90, good. So now, the question asks you to calculate the angle of BAC. Now, BAC, when you ask you to find the angle, right, always identify the angle first. Okay, for trigo standard, for trigo questions usually is very standard. Okay, this will be inside a triangle. You make use of that property inside the triangle. So this triangle got what? You have a length, and a length. Okay, is this a right angle triangle? No, right? Clearly it's not, right? So if it's not a right angle triangle, you can use the following formula. Half AB sine C, cosine rule, sine rule. Now, cosine rule, the formula, right, has 3 sides plus 1 angle. For sine rule, is 2 sides and 2 angles. Okay? Based on this information, do you think I will be using cosine rule or sine rule? What do you think? Cosine rule, right? Because I got 3 sides, I'm finding 1 angle. Okay, so that fulfills the criteria of cosine rule. I should not be using sine rule, right? So in my formula over here, I will use 55 squared, okay, because the angle I am interested in is your BAC. So the side that must be in front is the side that's opposite the angle, which is 55. That's why I put 55 in front. Okay, and remember, it's square. You have a formula sheet. Please open your eyes and copy properly. Okay, don't be that one fella. Yes.
In their exams, are we allowed to detach the formula?
Good question. I remember I didn't do that. Just before. Okay, I remember I didn't do that but okay, let's stop at that first. Okay, because I want to say JC there is a separate formula sheet, like it's detached from me one. Okay, once you have this ready, right? Okay, include your 2 sides. Okay, everything. Okay, cosine BAC. This is the one you want to find. Okay, then some of you ask me, sure, after I rearrange already, right, I get cosine BAC equals to this thing, right? Sometimes this value will be negative. Is there anything wrong? No. Why? Because your angles can be obtuse. That's why there's nothing wrong. Okay, if you think about it, your non-right angle triangle can be obtuse. What? This part is obtuse, right? Okay, so your angles are allowed to be obtuse. That's why it can be negative. Okay? Can I, Chloe? Okay. So this part is just computation lah. Solve already, finish. That's it. Very fast. Okay. There's nothing to take down, I think. So is there anything to take down? No, I move on first. Okay, but anyone don't understand? Okay, I move on, Okay, next. I'm going to do something that is a little bit high tech. Just give me a moment. Okay, I'm going to crop this guy to the next page so that you guys can see, or rather so that I can see lah. Okay, and for the benefit of those who didn't manage to take down, I screenshot for you so that you can see lah. Okay. Okay, a bit not nice, but I think here is good. Okay, so calculate angle DAC. Okay, DAC is actually over here. Okay, and it's inside this triangle, right? So this triangle, right? What do I have? I'm finding one angle. I got another angle. I got one side. I got two sides. So what can we use? Sine rule. But sine rule, you must check, right? Whether the sides are opposite the angles, right? So this 50, right, is indeed opposite that. This 50 degrees is opposite the 50 meters, right? And this 60 meters, it is not the same. It is not opposite the angle. So what do we do? Sorry? Did someone say something? Find angle ADC. Then, after that, well done. Okay, so in this situation, right, don't panic. Because as long as you got two angles, right, you can always find the last angle. So, if you can't find DAC directly, it's fine. As long as you got two sides, right, you can always find your last side one. Very simple one. Okay, so the first thing that you need to do, okay, is to find your angle ADC first. Then after that, you use the sum of angles in triangle property to go and find your DAC. Okay. Always ensure that your intermediate workings are in your 5SF. Okay, I think you all should know this already, right? So intermediate working 5SF, that's it. Okay, so step 1, find the dummy angle. Then find the actual angle. Okay? The back row very happy. Okay, good. I like happy people. Okay, can I will scroll down a little bit. Okay, anyone need to take this down? No, Chandran, okay, right? Are you Chandran? Yes, right? Okay, you okay, Okay, tick. Now, next one. Let the north line drawn be the... what the question is this? Okay, sorry. Calculate the bearings, right, of A from D. So let me go back to this diagram over here. Okay, the bearings of A from D, right? Okay, they say from D means your D is your reference point. So you need to draw the north from here. Okay, always remember when you grow your tree, you always grow from a point that you need to start from. So if you start from D, right, you grow your tree at D, then tada, your north line come out already. Okay, so you need to find the angle, this angle over here. Okay, but then how to find the angle? So according to the solutions here, okay, you let the north line drawn be N1. Okay, so this is N1. Okay, now what we can do, right, is this angle over here, okay, is equal to this angle over here. Correct? Because since you have north and north over here, right, these two are parallel. You can use your parallel lines property. Okay, and the parallel line property, if you only see parallel lines, right, then you can use. So the acronym is this one, CIA. Okay, corresponding, interior, and alternate. Okay, I'm sure you guys remember this. Okay, if you don't remember this, please go and revise this. Okay, so now we can find this angle over here. Okay, which is what we already have at the start. Okay, so you just need to add them up, you will get this angle. Then once you have this already, okay, once you have this, you will then have this, right? Then apply angles at a point to subtract this point away to go and find that bearings. Okay, that's it. Can? Simple, Okay, can. I'll leave this for another 15 seconds. Let you take down a bit first. Okay, the next question I will go through, right, will be question 2. I will not go through question 1. Because question 1 a bit simple. Okay. Okay, I will go through question 2. Okay. Okay, so let's have a look at question 2. Okay. Now the diagram shows where everybody is at this page. I give you some time to go and flip to this page. Okay. Design and remote, okay. Finding the page. Treasure hunt. Okay. Now let's look at question 2. Okay, question 1 you can go and try yourself. Okay. I will release the answer key later, don't worry. So now the diagram shows 4 towns, okay, A, B, C, D, on a horizontal piece of land. So town A is due west of town B. When you see the word due west, means A is on the west of B, correct? Remember, when you say due west or due south, right, you can insert your 90 degrees or your 180 degrees. So in this case, this is a right angle, correct? Now ABCD is a trapezium such that AB is 0.9. Now what do I mean by trapezium? What properties does a trapezium have? Yes, parallel lines, right? So which two will be parallel? Okay, so obviously, thank you, Ananya, right? Okay, so when you need to ask yourself, right, can AB and BC be parallel or not? Cannot be, but it's obviously not parallel, right? So it has to be the other two that's parallel, right? So what else do we have? AB is 0.9, AD is 1.2, and angle BAD is 150 degrees. Okay, calculate the distance between town B and town D, which is this angle, right? Okay, so whenever you need to do this kind of question, like calculate distance between B and D, right? You draw a line first. Okay, that helps. Then, in other words, once you have that already, right, you know that, okay, I'm going to find this guy over here. But then, when I draw that line, right, I split this trapezium into what? Celeste? There's two Celeste, right? Let me ask you. What does this line split this trapezium into? What is it shape? This one? Right? So you cut this into two triangles, right? Now, which triangles do I have information on? The top one or the bottom one? The other Celeste? Is there another Celeste? There is, right? Don't have, only got you. Okay, can. Come, tell me which one you think we can work with, top or bottom? The top one, right? Because the top got all the information, right? So let's take a look at the top one. Okay, we need to know this guy. Okay, what do we have? We have length, angle. Which rule can we use? Sorry? Sine or cosine? Why sine? Sine, you need how many angles? So is which one? Cosine. Okay? Thank you, Sarah. So cosine rule, you have this guy, you don't know this guy, okay, but you know the opposite angle. So based on this, right, okay, my formula would then be BD squared, okay, equals to the two sides, you square them individually, you add up. So it's 1.2 squared plus 0.9 squared. Then according to the formula, is minus 2 times the two sandwich lengths, right? Your 1.2 and your 0.9, right? Then you apply the cosine of that angle. That cosine of the angle is 150. So just plug that in. Okay? Then this part you can just calculate. Use your calculator. Now let me warn you guys, your calculator is supposed to be in degrees or radians. Degrees, okay? Don't go and put radian, Don't take AMF especially, you go put radian, die. Okay? Always remember degrees, So this one you get 4.1206 by SF. Okay? And then after that, once you know your BD already, right? BD squared, right? BD will then be the square root of this answer. So your final answer will be 0.23 kilometers. Okay? Okay? Okay, I will leave this for a while. You want to go and take this down. Uh, here, 4.126. Wait, let me write down nicely a bit. Okay, can? Better, Okay, I will be honest, my handwriting is not very good. So if you all need me to rewrite, please let me know. Can? Okay, can. Let's move on. Yes.
You should take 150.
150. Then what did I put? Oh. I intended to put 150 lah. Okay, sorry, my bad. Doesn't look like 150, I agree. Okay, can You guys okay? Teresa can? Can Okay, can. Okay, next. Can I move on? Okay, what I'm going to do, right, is once again, I'm going to erase all of this fella. Okay, and then I'm going to crop this guy to the next page. Copy. Bring back. Go here. Okay, so like that. Now find the angle BDC. Okay, so I think I already know that this part over here, okay, is 2.0299. Okay. And now we want to find angle BDC. Okay, BDC is over here. Okay. So this one over here, right? Okay, BDC, this is the angle BDC. Okay. This is no, okay, like that. Okay, we want to find this angle over here, right? So here's the thing. We want to find this angle, but it's inside this triangle, right? Do we have enough information to execute anything there? No, right? Okay, so what do you think I need to do? Find BDA, right? BDA, okay, which is this angle over here, right? Okay, why do you think we will use BDA? So you can use your parallel properties, right? Okay, so actually for this question, I don't think it matters whether you use you find ADB or you find ABD, right? Okay, as long as you're able, because if you use ADB, right, you will find this four angle and you will apply what? What are these two angles? Interior angles. Very good. Okay, and then if you use ABD together with this one, right, they are related by what? Okay, let me just draw this out. So if let's say you find this angle, you use this one, right? Why is this? Thank you. Alternate angles. Okay, so let's take a look first. The question, we will find BDA, okay, which is this one. Okay, so for BDA, right, this is the unknown angle. We know one more angle, right? So what is the rule that we'll use? Do we use cosine rule for this? Or do we use sine rule? Sine rule, okay, so we got two angles, right? You got two sides, right? You use sine rule. Okay, so obviously these two are related. These two are related. Now the good thing about this is that you have three sides, so it doesn't really matter which side you use lah. Okay, so we will have sine of angle BDA. Okay, BDA is the one. Let's highlight BDA is here. Okay, the side that's opposite this guy is 0.9. So let's key that in as 0.9. Then it will be equals to another known pair of angles that we know. Okay, since we know this guy, okay, the 2.299, right, and the 150, right, we will use that one. Okay, so we'll key in sine of wrong. Sine of 150 equal over 2.0299. Okay, you form this equation, you get marks already. Okay, so for EMAth, usually you form the equation, you get marks already. So if you don't know how to solve or what, right, just bomb the answer out. You will get some marks. Make yourself have a bit of hope lah. Okay, so once you have this ready, right, you need to make this guy the subject. Okay, so sine of angle BDA, okay, is equals to, now this is a fraction equals to a fraction. So how I taught my kids, right, is that you can use the escalator. This 0.9, you can go up, you can take the escalator, go up. Then you will be left with sine BDA. Then everything else is on the other side, right? So you take escalator, go up. That's how I teach my cross multiplication. Okay, so sine BDA, right? You will have 0.9 times sine 150, okay, over 2.0299. You will get 0.22168. Therefore, angle BDA, you just apply your sine inverse, you will get 12.8077 or 808 lah. Okay? So find SF lah. Once you have this already, right, you will then realize that, okay, I know that this is 150. I know that these two are parallel. Okay? Since this guy is 12.808, right? Okay? I know, first thing first, that these two are interior angles. Okay? You all can see over here, right? That's my interior angles. So I will take 150 subtracted from 180, right? I will get this angle over here. So this part over here, okay, in red, must be 30 degrees. Okay? Leroy, Sarah can see, right? Okay, so therefore, my final part, okay, I will have angle. Let's see. Angle BDC is equals to 30 minus 12.808. Your final answer will be around 17.2 degrees, 1 dp. Okay? Always ensure that your angles are corrected to 1 dp. Okay? If you all don't remember this, right, it's in the front page of your answer booklet. They got say one. They will tell you specific instructions on what to round off. For angles, always 1 dp. For everything else, not exact, 3 SF. They got say this one. So if you all say your teacher never tell you, it's in your booklet. Everything is inside there. Your O level also. Okay? So that's it for my part B. Okay? Now, I will leave this for 30 seconds. Go and take down everything. Blah, blah, blah. Okay? I move on to part B, C. Okay? Now, once again, I'm going to copy this guy down. Haha. Okay, calculate the bearings of D from B. Once again, the roots is from where? B, right? Not D, Boy, B for boy, right? Not donkey, right? Okay, so boy, I draw the knob. The knob is already there already. Very nice. Okay, so where is D? Okay, D is over here. Okay, so the angles I need is this guy over here. Now, what is the easiest way to calculate this angle? It's not so easy to calculate this angle, right? The blue arc, right? Okay, so usually if it's not easy, you find the what do you call that? The complement event. You all never learned set 4 set notation yet. You will find the other part of it, which is your angles at the point. Okay? And remember, what did I say at the start about the angle? Right? This part over here is 90 degrees. Do I know this part? Yes. How to find that part? Minus the answer just now, right? Which is your 17 point wrong. Your 12.807. Wait. Oh, never mind. Actually, never mind. I realized something else. This angle over here is the same as the angle, right? Because why? Alternate. So actually, you don't even need to use sum of angles in triangle. You can just use alternate. Okay. Since we already know that this is 17.192, right? Okay, you just need to alternate angle that one. So therefore, the bearings, right, is just 360 minus 90 minus 17.192. Your final answer will be 528 point wrong. 252.8 degrees. Okay, 1 dp. Okay, so just need to make sure that you know how to bring up to the guy over there. Okay, the reason why I say you need to take the green color arc instead of the blue one is because this arc over here, how to find? Not easy to find, right? So that's why sometimes you need to think, okay, is it convenient for me to find that angle or not? Okay, there's no nice angle for me to use, right? I can't work from there. So let's try the green one. Let's try the other guy. Okay? Sometimes you think this way, you crack your mind already. You will know how to do it. Okay? Okay, and last but not least, once again, I let you copy first. Liver can Can see or not? Can? Okay What are your names again? The two behind. Never mind. You're shy. Hey, never mind. Is that okay? Can How's it so far? Good Okay, good. Anything is better than the teachers that you tell me Okay, can. Let's move on. I think area's okay. Let's move on. Now, a tower is standing at town B. Okay, so there is one tower. Okay, let me just draw out the tower. Okay. No, this is not a wizard tower. It's just a tower. Okay, it's on top of town B. Now, the greatest angle of elevation from the top of T, right? From the path CD. Okay, CD is over here, right? Okay, so you just imagine one fella over here, okay, is walking back. No, let's draw over here. Okay, one guy decides to wait yeah, better. Okay, so one guy decides to walk along here. Okay, but ask yourself, where will you ever have a shortest distance? Okay, your shortest distance will be somewhere around here, right? The idea is that when you walk along here, okay, this guy okay, wait let me think of it this way So you want to have the greatest elevation of the greatest angle of elevation, which means basically how this works is that you just imagine this guy is at this guy Okay, the two blue lines will meet at the person over there. Okay, so you are allowed to move this around, but what angle would this be? What is this angle? 90, right? Because it's legitimately just stand upright Okay, so this is right angle. Okay, if you want to maximize this angle okay, you think about it. This angle will be influenced by the blue. This angle will be influenced by this, right? Correct or not? So in order to maximize that angle, this guy should be longer or shorter. This line should be longer or shorter. Sorry? I thought you said something. Okay, guys, if you want to maximize the angle, do you want that red color arc that I draw, right, to be longer or shorter? Shorter, right? Because the shorter it is, right, the higher the tower have to be. Okay, so you want to ensure that this guy over here is shortest distance. Okay, clear? You can visualize, right? So how do you have the shortest distance? Okay, so the idea is that usually your shortest distance is when you meet a right angle with your DC, as I mentioned to you earlier on. Okay, from B you look at DC, you look at a straight path. That angle is confirmed right angle, right? So no, I don't want this guy. Okay, I want this guy. Okay, so let's take it one step at a time first. Okay, I need to settle this part first, right? Okay. So the question now is, how do I find this angle? Okay, how do I find the angle? Based on the information that we have earlier on. Okay, this is the information that we have, right? Okay, so to find this angle, once again, the bottom triangle, I got not much information I can use. So I may need to refer to the triangles on top. Okay, but the only thing I have, right, is that this, okay, this arc over here, right, this length, this distance, right, is 2.0299. That is the only thing I know. I also know that this angle, right, is 17.192. Is this enough information to find this distance or not? This shorter distance or not? Enough, right? Okay, so sometimes the thinking is like that. Okay, you need to find out which triangle is this height involved in. Okay, obviously not the whole thing. It's only part of it. So when it comes to shortest distance, because got right angle involved, right? Your technique is tuakaso. So just look for your tuakaso, right? Look for the sides that you need to have. So in this case, I got this, I'm finding this guy. Okay, so therefore, the sine of BDC, okay, which is this angle over here, okay, is equals to the shortest distance, which is your opposite, okay, your opposite over your hypotenuse. So we will then have D over 2.0299. So from there, D is equals to 0.599. This is so weird. Okay, but I think it's around 0.60000 lah. Okay, I mean, to be honest, it's like that lah. Okay, so this is your 5SF. Okay, subsequently, once you have that shortest distance already, right, then you are able to draw this guy is your shortest distance. Then this is your tower. Okay, I draw the tower for you guys. So this is the tower. This angle over here is 18. Okay, they want you to find the height of the tower, which means I need to find that guy, right? And that guy, once again, reference to the 18 degrees, right, is which side of the right angle triangle? Which side is this? It's the right angle triangle, right? So that tower, right, with reference to 18, right, what is it? Again, opposite. Thank you. So opposite, and then we got hypotenuse, right? So therefore, okay, sine of 18 is equals to your opposite over your hypotenuse, which, okay, do we know hypotenuse or not? Don't know, right? But do we know the shortest distance? We know. So we use that one instead. Okay, so it's not sine, okay, it's tangent. Okay, because we know O and A, we use the tuakaso, right? TOA. So we use this. And then from there, you figure out your opposite is equals to 195 meters. Okay, 3SF. Okay? Now, there is some intermediate steps, because everything that you all use so far, right, is in kilometers. Correct? So one of your intermediate workings, right, would then be 0.194947 km, right? You will need to convert this into meters. Okay, so just be very clear about that. Okay, let me write a bit nicer. Okay, so this part over here, you need to ask yourself, find shortest distance first. Then you find your angle of elevation. Or rather, make use of angle of elevation, right, to produce your tower length. Can? You okay? Zoom in. I like this. Good enough? Can. Okay. That was tiring. That was just one question. Okay, at this point of time, anyone got any issues? Is that okay? Is this your weakest topic? Don't know. You don't know what's your weakest? Okay, no worries there. Okay. Let me just leave this for 30 seconds. Then after that, we'll move on to the next part. Yes. Zoom out, Okay. Okay, everyone doing okay, Okay. You're still running down. Who still need more time? No, Can, Okay, can. Let's move on to the next part. Okay. Now, this is on congruency and similarity. Can I have a show of hands, who hate this topic? Okay, let's higher under C. Whoa, that's a lot of people who hate this topic. Okay, can put down. Can put down. You're okay with this topic? Zihan and Wigmore, you're okay with this topic? So okay, can. So for congruency and similarity, right? Okay, this one, I know that more people will hate this topic one. I think Chigo is fine. Okay, so the main thing I need you to know, there is your congruency test and your similarity test, right? But then I can put them into one category. So let me just show you what is going on. So I'm going to categorize them as the following: similar and this thing called an upgrade. Okay, and then the other side is your congruency. Okay, so in Sect 2, you might have learned that your similarity and your similar and your congruent triangles, right? Okay, you just need to calculate certain stuff. That's it. They tell you that it's similar and it's congruent. They never tell you to prove. Okay, Sect 3, you are forced to prove everything. Okay, so the main thing I need you to know, okay, is that for similar triangles, okay, I have the following properties. Okay, AA property, triple S property, SAS property. Okay, I only got these three for your similar figures, right? In particular for triangles, So SAS and SSS, right? You will notice that they are repeated in your congruence test. Okay, so what's the difference between a similar test and a congruent test? Anyone? Ryan, you want to try? So what is the difference between SSS and SAS, right, in similar figures and congruent figures?
So for the sites, right? For similarity, you want to make sure that going to find.
So when you compare two triangles, right, you're looking for the start letter R. Ratio. Okay? But in the context of congruence, right, your ratio must be 1. Because the two sides are equal, right? Your ratio will be 1. Because the proportion is equal. Okay, so the upgrade to SSS and SAS is that ratio. Okay, here the ratio, right, is not equal to 1. Here the ratio is equal to 1. Okay, for these two. Okay, that is your very straightforward upgrade. So you will use SSS and SAS for both. Just that you must know when. Okay, and one more thing, your A over here is like your cosine rule, and your half AB sine C must be included. That's why your A is in between your two S's. Correct? Okay, now the upgrade for AA property, now why is it AA property? You see, when you learn Sect 2 similar figures, right, you will learn that the shape is the same, the size is different. What do I mean by the shape is the same? When I say the shape is the same, means the angles are preserved. That's why it is sufficient to prove that two angles are the same. Why don't you need to prove the last one? Why don't you need to prove the last one? Exactly. Okay. Thank you, Clary. So now this part over here, okay, you only need to prove 2. Okay. Now what's the upgrade of AA similarity test to congruency? What do you think? Okay. So the one thing about congruent figures, right, is that not only shape must be the same. What else must be the same? Size. So if the size are the same, right, what must you ensure? There is at least one pair of equal size. So the upgrade to AA similarity is AAS. Oh. Okay. AAS similarity. AAS congruency test. So the upgrade is one side. And please ensure they are corresponding. Okay, not any random side, okay? They must be corresponding sides. Okay? Then you will have congruency. Okay? So that is the upgrade. Then the last one is congruence, what we call congruent privilege. Okay? There is this RHS. Okay? So RHS, okay, you need to prove there is one right angle, literally a right angle, one hypotenuse, and one random side. Okay, whichever you want. Okay? So this is only exclusive to congruent tests. It's not for similar tests. Okay? And so the one thing I want you all to take away, right, okay, is that your sides, right, okay, for your congruency test, right, you must always ensure that one side is equal. you don't have to do that for similar tests. Okay, similar tests, not everything involves S1, and the S is all ratio one. Okay, whereas for congruency tests, everything got S. So this way, I hope you all understand how to remember your different tests lah. Okay, I put in this table. I hope it's helpful. Okay. Yes. Yeah.
Why you right?
Oh, right. My bad. Thanks. Right too fast. Okay. Thanks for spotting. So basically, yeah, your similarity side not equal to 1. Your congruency side equals to 1. Okay. Thanks, Ryan, for the spot. Sick. Okay, I will leave this for 30 seconds. For those online, take photo or whatever. Okay. Then after that, we will move on to the next part. Okay. Okay, actually, I'll just add on lah. So basically, when you want to prove that two angles, never mind. This one we do in the example. Okay. Justification wise, I will show you all in the examples lah. Okay, not to worry. Now, for areas of similar plane figures and volumes of similar solids, okay, flip to the page 19. Okay. Next page, okay. Now for this one, right? Okay, you just need to ensure that they say that two shapes are geometrically similar. Okay, the keyword is geometrically similar. Okay, that is the keyword you must see. Or they say something equivalent to this, but usually geometrically similar is enough. Now, I just want to warn you guys, this question can cross topic with things like your statistics. Okay, your pictogram, right? They can cross topic with this kind of concept, but not to worry. So for now, right, what you need to know, right, is that when two shapes are geometrically similar, right, when it comes to a cone, for example, you have what? What are your main features of a cone? What do you have? What makes up a cone? You got a radius, right? What else do I have? I think what else do I have? Height, right? Okay. Any more? Again? Circumference, okay, yes. Okay, why is it circumference also work? Because circumference is 2 pi r. Your 2 pi is constant, but your r is also in a ratio. Right? What else? Slant height. In a way, it's also similar, okay? So, the ratio of your height, okay, of big cone, small cone, is the same as the radius of the big cone over small cone. Okay? Then, once you have this relationship already, right, you can then proceed to solve. Okay, so this one nothing much to take note of. You just need to know that for similar shapes, right, when you compare shapes, right, you always look out for the smallest unit first. Your radius, your height, that kind of stuff. Okay, usually we won't touch until circumference lah. That one very rare. Okay, but basically radius and height. Okay, next page. For area of similar plane figures, okay, you just need to remember that the length, the ratio of the length, right, you square it, you will get an area. Okay, this is similar to when you find your map skills, right, your area, right, you square both sides. Correct? So for example, 1 cm is to 0.5 km, right? You go and square both sides, you get 1 cm squared is to 0.025 km squared. Okay, I might be wrong, let me just double check. Okay, yeah, I'm wrong. Okay, so the idea is that when you square it, you will you see the formula is the same, right? You square both sides. So this applies to your area as well as your volume. Okay, volume is cube because it's 3-dimensional. You will take to the power of 3. Squares or areas in general is 2-dimension, so you will square it power 2. Okay, this one very straightforward. Now, let's look at the example. I won't go through the word example. Okay, I will go through example number. Okay, I will go through question number 2. Okay, so flip to this page, page number 24. Okay. Okay, so this is what we have. The diagram shows a triangle ABC. Okay, LMNB is a parallelogram. Huh? Is there something? Oh, sorry. Okay. LMNB is a parallelogram, and L and M are the midpoints of AB and AC respectively. Okay, so for example, they tell you, right, this is a parallelogram, right? So what are some of the features of a parallelogram? What do y'all know about parallelogram? Parallel lines, right? What else? Specific to the angles, what do we know? Interior angles, right? So this one is interior of this one, right? What else? The most famous one that nobody talk about. Yes, angles opposite. Very good. Okay, so angles opposite of what? What is the shape? What shape is this? So it's opposite angles of a parallelogram, right? Okay. So basically, this one I will just write down first because I think not many people remember this. Okay, so this one is opposite angles in parallelogram. Okay, this only works for parallelogram. Okay, so this is one of the theorems you can use. Some of y'all, maybe y'all forget this, right? You will use interior angle twice. Okay, so I'm telling you, y'all can use this. Okay, I teach this to my Sept 1s as well. Okay, now that we know this, right, we go to the question, the information. Midpoint of AB. Sorry, L is the midpoint of AB, which means this is the same as this. Okay, and then N is the midpoint. M is the midpoint of AC. Correct? So now, our job is to prove, okay, that these two triangles are congruent. Now, I know some of you guys are stuck at this. So the one thing I will tell you first, right, is I know I want to show ALM is congruent to MNC. And by the way, WTS not what the shit. Okay, it's want to show. Okay, so what do I write? I will put the letters as follows: ALM and MNC. How many of y'all see this for the first time? You. Serious. The rest of y'all see before. I secondary school never learned this before. Damn. Well, how does it teach you?
Oh, you just see, compare the sides and then.
Just eye power lah.
No, not that. Write it down. Like, for example, this is how we do this section. Like, for example, ED. Then we can write. Then at the end you say this triangle is congruent to this triangle, and you say that.
But is it intuitive? Not always, right?
I mean, to extend this.
Okay, so that's why this kind of proving, right? You usually try to work backwards so that at least you know how to connect the dots lah. Okay, so what I will do is I'll draw lines connecting AM, LN, and MC. Okay, so how do we do this? Okay, we need to compare angles these two triangles, right? So let's take a look at the triangles first. This one, okay, we want to prove it that is congruent to MNC. Okay, so the first triangle that we have, right, is what? We have this angle. Okay, let me use another color. Okay, this angle over here is supposed to be equal to this angle over here. But how do we know? Is it easy to show or not? Can you use corresponding angles? Sorry? Letter F. Oh. This one corresponding angles. Okay. Can you use corresponding angles or not? How do you use corresponding angles for this? Okay. Cannot, right? Actually, you realize it's cannot one. Because why? This side, right? In order to use corresponding angles, right, you must ensure that there are parallel lines. But you can't really do that, I think. Okay. Now, some of you may ask me, hey, sir, these two lines are parallel what? Correct? Did the question ever say that AB is a straight line? They only say it's a midpoint what? Did they say it's a straight line or not? Don't think so, right? Maybe I'm wrong lah. Maybe I'm wrong. Okay, but I think it's not so easy. It's not so intuitive to use that. So let's try something else. Okay, we can maybe use ALM and MNC, right? So ALM. So we are using these two, right? Now this one, is it easy to show that these two are equal or not? Actually, yes, it's quite easy to show, right? So first thing you need to know, I can move this down. And I can move this down. Like that. Okay? So straight away, okay, ALM is equals to angle MNC. Because why? Because I apply corresponding angles once and twice. Okay? So corresponding angles. Okay, I have LM is parallel to BN, right? Okay. Now some of you maybe you don't want to skip steps. Okay, so we will do this first. We will do LBN first. Okay, we know that this one will move down first, like so. Okay, so one time we move down. Okay, then after that we shift to the other side. Okay, so the next one, right, we use the other parallel lines. Okay, these two, right? So the next one, ALM is equals to angle MNC. Okay. Okay, right. MNC, right? Okay, because corresponding angles LB is parallel to NM. Okay, so this one will give me the first angle. Yes. Produce, right? Okay, the reason I think is possible, but I don't want to go to that, and I don't want to go to that because I think it's ambiguous. Okay, now I only know that L is the midpoint of A and B. I don't want to assume there's a straight line, unless no choice. Unless really no choice, then I do that. You don't make assumptions, lah. Okay, that is the rule of thumb. If really no choice, then you do that. Really no choice, then you can do that. Okay, but usually there's a way out one lah. Okay, now that I settled my first angle already, right? I need to know the other angles, right? Okay, for example, do I know that this angle is the same as this angle or not? Okay, maybe not, right? Or how? What can we do? Okay, so this angle and this angle, right? How do we then show that these two are the same? Midpoint? These two, how does midpoint help me to move this down? Does that what? Say again? AM equals to MC. Yeah? So, so this is equal to this. Okay, can. Good. So AM equals to MC, right? And it corresponds because AM, MC, right? It corresponds. So these two and these two links, right? So this is my the reasoning for this is that M is midpoint of AC. So therefore AM equals to actually don't need to write this already lah. Okay, can. So you got one side and one angle. What else can you use? What else? Say again. AL equals to MN. How do you know? Midpoint. Okay, yes, you're right. So this one, right? Okay, let me just show you guys. This over here is the same as this over here, correct? But then because that's a parallelogram, right? So it must be equal to this guy. Correct? Can see? So Ryan, I never make any assumptions, right? Never. Okay, so your next line will be AL is equals to LB equals to MN. You will then state, okay, reason L is midpoint of AB and LB is equals to MN because of parallelogram. Okay, so this part we use wait a minute. So our length, we know this one, right? Then the angle is which one? Over here. All right. So what's wrong? This is a S and S, right? All right. You want to use SAS dash, right? Your angle must be what? included. Is it included? No, right? So actually it's not correct. Okay? So if we can't do that, right? Okay, then we need to use something else. Okay, but good try. We are heading in the right direction. So if we can't use SAS, right, then we use the no choice method. Okay, so what do I mean by no choice? Okay, so we take a look. Let me just show you what's going on over here. So now we know this guy. Okay, we know this angle. Okay, if we can't use SAS, can we use another one or not? Can we find another angle? Okay, so this angle this angle probably not usable lah, but this one maybe we can. Okay, so we go back to this. SAS cannot work, right? We use AAS. Because we already got one angle on one side, Okay, SAS, the thing is too restrictive already. So we fall back to AAS. Okay, now AAS, okay, we need to prove these two are equal. So then we realize that, okay, we can probably shift this down, right? If we know that LM is parallel to BN. Correct? Then this one, right, we kind of no choice already. We need to extend it to BC. Okay, so let me just write this down. Okay, let me just cross this out first. Okay, we will then use, okay, the following property that let's state first that LM is parallel to BC. Therefore, angle AML is equals to angle MCN. Okay, so this is your last angle. This is your side. Okay? Okay, let me zoom in a bit. Yes. Sorry? Okay, let me go back to this. Now, just now, right, the angle that we show, right, okay, is this angle. And the length that you show is this one and this one, right? All right. Now, SAS requires your A to be sandwiched between the two sides. Do we have that? No. So that cannot. Okay, so simple. Mathematical terms is already very cheap already. Why you want mathematical terms? Okay, I write like that, right? Okay, you know this guy, you know this guy. So sandwich, right, means these two are your known sides, right? Sandwich means in between. Okay, you refer this to your cosine rule and your half AB sine C. It's exactly the same thing. Okay, so then we have this, right? Okay, by ASA test or AAS test, okay, ALM is congruent to MNC. Okay, that's it. Okay, let me zoom in for you guys. So earlier on, right, we got stuck at the part of SAS. Okay, we cannot prove it that way. So we undo one step back and ask ourselves, we got one angle already, one side already. Correct? Confirm cannot use SSS what? Then we use AAS no? If you can't find the last side, we just find one more angle and bomb our way through. Okay? Can? Yes. ML, AML, MNC. Can? Sorry. MCN. Yeah. That makes sense. Yes, that makes sense already. Sarah can? Okay, thank you. Okay, that is for the one question. Yes. Hey, go. Yes. Oh, go. Okay. Let's take a break first. I think everyone's a bit overwhelmed by the first few part. Okay, let's take a break first. Okay, come back in 5 minutes. Ryan, your doubts okay? Settle your doubts really? Your doubts okay? Yes, ask.
What is the reason why here I was able to upscale? Sorry, let's see.
Okay, come. So this part is the one that I mentioned, right? That originally we said you cannot assume that extended is parallel, right? But in this case, kind of no choice lah. So why is these two equal? It's because this guy can slide down. But how do we know can slide down? It's because this is parallel to this. But then if you produce it, right, it's parallel. Corresponding angle. Oh yeah, that I never write that one down. So you write that one down, All right. I will highlight this to everyone when everyone's back. Okay, thanks, Ryan. Yes, come. Huh? Zoom in, yes. How everything okay? Can eat my dinner already. Hey, sorry, I need to close the door. I just know that you don't. Okay, that's okay. But how do you have that's all. Not problem. Everything okay? Yes. So, how do you do it? Oh my God, who said? Yeah. Oh, yeah. Yeah. Angle of the question is okay, just hold on. Talking I will do like it is about you, right? Do your picture. Look, yeah. About you, angle of the question of A from B, right? It means you look down. Okay, so when you say from it, right? Well, okay, because H is supposed to be above. Okay, so this is above, it is above B, right? This is correct. Although, on the other side, correct. Okay, so because right, angle of reflection is wrong, you okay or okay. So you are actually on top looking down. Okay. On top looking down, right? This is important. It doesn't really go far. Yeah. So I think you're right. If you talk again, okay. 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 Then because this is parallel to right? Okay, but I know that you look down to the floor. Okay. If you draw everything like this, I think right. This is right. Because you know it's completely above right. And A is something around. Correct? You look down. This one is not. You don't focus on the rest of work, you focus that it is directly above. Correct? That A is over here, right? This is what is over. Okay, then you find the height above 5. So any of these probably know this, right? Right. Alright, see. Okay, is there a back? Okay, can you help me put four? Okay. Yes. Oh, sorry. Why cannot SAS? For the first angle, can use alternate angle. Actually, come to think about it, I think can. Because if you extend this, right, then this will be parallel to this. Wait, Chloe, you can hear me, right? Okay, so this two is parallel, then you can use this already. Okay, your lightning already. I think it's like that lah. Okay, then once again you use your alternate angles like that. Can? But why cannot use SAS, right? It's because like I explained already, right? You know this length and you know this length, correct? The angle that we found is this angle over here. Okay, but remember SAS must be in between the two known sides. So this angle over here is not included. That's why we cannot use SAS. Is that a bit clearer for you? Okay, she left. She's back. You help me see whether she understand. Okay, for the rest who are here, right? Can I just check? Anybody got any issues with this question? Or everyone okay already? And okay. Chloe, you let me know if you got anything else. I can't. She say okay. Okay, good. I said this just now. She never hear. Okay. I will go through probably one more question for. I'll go through one more question related to our similar figures. Okay. Now, for similar figures, okay, diagram shows a rhombus ABCD. Okay, over here. Okay, and then O is produced at AD. Okay, which is like this, right? Okay. I think I take back what I said. Okay. When it's produced, right, you can just take it as a straight line. Okay, Ryan? Okay, can. So when it's produced, right, because it must produce in a straight line. I take back what I said. So this ADO will be a straight line already. Okay? Don't know why I say it's not a straight line. I'm a bit stupid. Okay, then rhombus ABCD. Okay, so this is a rhombus. And if this is a rhombus, then all sides will be equal. Okay? Now, O is on AD produced such that AO is equal to 2AD. When you see this, once again, these two are equal. This will be equal. This will be equal. So everything over here will be equal. Okay, and then they say that BO, okay, BO is over here. Okay, BO intersects AC and DC at F and E respectively. Now, then the question asks you to find, to show, okay, that triangle ODE and BCE are congruent. Okay, so give a statement, give a reason for each statement. So ODE is here, okay, and BCE is here. Now, immediately, what can you draw from this? What can you conclude from this? Say again? Who said something? Oh, I thought someone said something. Is it? You look at these two angles, right? Okay, you draw out your ODE and your BCE. Okay? Immediately, what can you conclude? Isaiah, you right? Which side? Very good. BC and DO, right? They are on the same side of that so-called the thing that I draw, right? So you can straight away write BC is equal to OD. But why? Because you need to realize this one, there is a reason one. It's not random. Okay? It's because ABCD all sides equal, right? And because why? We know that AO is twice of AD. So therefore, we write down the reason as well that D is midpoint of AO. These two will be the reason why BC is equal to OD. Okay, thank you, Isaac. Now, next one. So we have the side that is equal already, right? Okay, what else can we infer from here? Okay, vertically opposite angle, right? Now, sorry? Huh? Oh, yeah, sure. Okay, so these two are opposite, vertically opposite angles, right? Okay. Now, because of that, next we can write angle CEB. Those who play Dota, you should know who is this guy, right? Okay, CEB is equal to DEO. Okay, because of vertically opposite angles. Okay? Can Sanjang can see, right? Okay. Then after that, you got one side over here. You got what? You got equal angles, right? And you got equal sides. So if you want to, now I will address this. Okay, for those who want to use SAS, for Chloe also asked me the question earlier on. The next thing to ask yourself is, if I, what is that? Oh, my earpiece. Okay, if I want to use SAS, right? Okay, ask yourself, I got this side, I got this angle. Do I have an included side or not? No, right? Obviously not, right? You see, this angle is opposite BC. How can it ever be included? Correct or not? So I cannot use SAS. Don't bother. Okay, so don't bother about that already. So if you can't use SAS, right, you need to show what? You have one side, one angle. If your next one is not an equal side, then it must be what? Angle. Very good. See, very simple one. Okay, you eliminate and you choose your options accordingly. So in this case, the angles that I want to prove is what? What? Alternate angles. Which two is alternate? DOE and very good. Who's there? Okay, never mind. I don't make your try. Okay, so DOE is equals to, okay, DOE and CBE. Correct? Correct? Okay, nice. The deer, the rain, I don't know. Okay, so this one, right, is because of alternate angles. Now, which two sides are parallel that allows you to use this? AD and BC, right? Okay, because this part is parallel to this, and then you extend it. So this must be parallel to this, right? You can't see my what? I move already. Oh, you mean you can't, it's blocking you? Okay, so that's all right. Okay, can. So here's the thing. You got one side, you got one angle, right? So by AAS congruency test, okay, CDE is congruent to ODE. Okay, now I thought I will highlight this. This last line over here must mention. You must always quote the test you are using. Okay, if not, you lose marks. Simple as that. Okay. Okay, so take this down. So I hope you all are familiar with when you should use SAS and when you should AAS. So I think when it comes to congruency or similarity kind of questions, right, you always look out for the obvious facts first. From there, you work your way up and see whether it works or not. Okay, this one is really from experience, then you will know one. Personally, I'm not very good with it. I'll be very honest. But the AMF one seems to be quite okay. Okay, let me leave this for 30 seconds, then I will move on to the next part. Yes? Am I doing AMF? Yes. You mean this Thursday, right? Yeah, correct. I'll be there. Physical, Yeah. Okay, nice. Anyone going for AMF this Thursday? Wow, okay, nice. I'll see you there. Yes. No, doesn't matter. But you must make sure that the side is corresponding. That's the only criteria. It doesn't need to be sandwiched or included. It just need to be corresponding. So cannot be telling me My hand is equal to my leg. Cannot be what? Then you walk like that. Right? You look a bit stupid, right? So cannot lah. Okay, your left hand must match left hand lah. Okay? But your head is always between your two hands lah. So your angle is always between your two hands. Cannot be your hand like that what? Okay? Okay, let's move on. Now, show that triangle ECF and B. Okay, wait. Let me take down again first. Okay, copy paste. Okay, so now we show that ECF, okay, and BAF are similar. Now, based on this, what property do you think will be so obvious to prove? Vertically opposite, right? Okay, and what else? Okay, can you use SSS or not in this case? Will you want to approach SSS or not? No, right? Okay, you got one angle already, right? What else do you need? Side. Okay, if you want to use SAS, right, you need to have two sides, right? Is it easy to prove with the sides or not? No. So what do you think how do you think I will approach? If I don't want to use sides, right, I need one more, another angle. Where can I find the last angle? Alternate angles. Okay, you have this option over here. Oh, the color not very nice. Okay, like that. Okay, or like that are also okay options. So let's write this down first. Okay, first, EFC, okay, is equals to angle BFA, right? Because vertically opposite angles, right? And then the next one, right? Okay, I use angle CEF equals to angle ABF. Okay, this one is alternate angles. And CEF is this angle and this angle, right? So which parallel lines did I use? I obviously use these two, right? So it's because of AB is parallel to CE. Okay, so therefore, by AA similarity, ECF is similar to BAF. Okay, do your two triangle sign, finish. Smiley face. Okay? So this one is very straightforward, not so complicated, right? Okay, I'll leave this for another 20 seconds or so. Okay, take this down. Sorry? Did I say something? Oh, okay. I think I misheard a wrong composition. Oh, I was wondering where is he? Thank you. Okay, can I move on? Still writing? Okay, I move on. Okay, can. Now the next part over here, find the area of ECF and BAF. Okay, so let's copy this guy down. Okay, now ECF is here. Okay, and BAF is here. Now, what do you think I make you prove these two? What do you think these two is? Have I seen this before or not? Have I used this before or not? Where? On top, right? Hey, thank you, Chan. Okay, so I already literally just proved seconds ago that ECF is similar to BAF. So if I want to find the area, right? Okay, what do I need? So to find area, right, I need to have what? Okay, so for this one, okay, let's take a look at what's going on first. Okay, so I know that since these two are similar, okay, we will then be able to compare the what? Ratio. Okay, but then that is not enough information for me to deal with this, because why? If I want to write half base times height, right, I need to know at least what the height of the base is. Okay, and that's where, right, I will bring in my part A. Oh, bless you. Okay, part A, right, what did we show? We show that ODE, okay, ODE is congruent to what? BCE. Okay, so ODE is similar to BCE. Okay, and what is the purpose of telling me this? Okay, because in order for me to make sense of this ratio, right, okay, I know that I probably want to compare AB and CE. But the thing is, I don't know how is CE related to AB. And that's where my first part comes in. Because why? If ODE is congruent to BCE, what does it tell me? It tells me that these sides are equal. Correct or not? Okay, DE and CE, they are equal. So that means to say what? E is the midpoint of CD. And if E is the midpoint of CD, right, what can I conclude? I know that CD is also the same as AB, what? Which means AB is actually twice of EC. S. Yeah, go ahead. Outside, turn right. No. Outside, turn left at the lift there. On the left side, when you go on the lift, right, you can see a toilet there. Can. So AB equals to 2EC, right? Then I can use my similar figures, right? Because these two are geometrically similar. Thank you. Okay, so these two shapes, okay, they are geometrically similar. Okay, so that's where I can use L1 over L2 squared. Okay, always remember there are two variations. Okay, type 1, similar figures. Type 2, you have same base or same height, right? Then there's a ratio for the other one. So for example, right, if let's say you got this kind of triangles, right? Okay, they have a same height, but then their base maybe is a bit different. Okay, so that's where you use the type 2. This is type 1, cause it's similar figures. Okay, so you need to differentiate whether it's type 1 or type 2. Can? So in this case, because these two are already proven to be similar, right? I will use L1 over L2. And since I know, okay, ECF is to BAF, right? Okay, ECF is the smaller one. So I will put CE over twice of CE, right? Squared. Okay, or I will write AB, right? Then I will write 1 over 2 squared equals to 1 over 4. Therefore, the ratio of the area is 1:4. That's my answer. Okay, so similar is not enough. Similar only tells you that you need to know one side can already, but I don't know any of the sides. So you need to prove or try to make a way out to relate the sides of, let's say, EC to the sides of AB. That is the only way for you to move forward. Okay, so that's why sometimes when you're asked to prove certain things, right, look back at all the previous parts, all your archives. Sometimes part B is not enough one. You need to look at part A. Okay? AMF is the same thing. Can? You know where to top up water, right? It's just outside there, the water cooler, if you need. Okay? Can I run? Okay, Let's move on. Can I move on, That's okay, Okay. Now, I won't go through this. You can go and read this yourself. I will skip to page, this question number 6. Okay? There's a reason why I choose this question, Okay? So this question over here, okay, is related to your, what we call the real world problem. Okay, because why? Usually this kind of question, right, I will ask you to blah, 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 justify your answer. Why, which is better? Okay, so let's take a look at this question. The diagram shows two geometrically similar can. When you see this already, right, immediately what you think of? What do you think of? Chloe? Don't ask you. Okay, Sarah? When I say two things are geometrically similar, right, what do you think of? Not necessarily the same. So for example, right, if this radius is R1, this radius is R2, right? Am I right to say that R1 over R2, you square it, you get the base area, for example? The ratio, you can scale up to volume and area, right? Not say same, yes, same ratio lah, okay? It will be the same as the height, so to speak. Okay, so height 1 over height 2. But the main purpose of me telling you this question, or asking this question, right, is to relate this to your volume and your area. Okay, so now you understand this already, right? We look at the question. Okay, so a soap manufacturer wants to fill the cans with soap. Okay, now let's read on. The ratio of the height of the two similar cans is 4:9. So I give you the height. I never give you radius, what? And then I tell you the surface area of the small can is 240 cm squared. Okay, then the thing is, by considering the materials and volume, right, we determine which can is more cost effective. So so the keyword over here is cost effective. What do I mean by cost effective? What is your main objective? Okay, so for example, this thing over here. Okay, what makes up this thing over here? I have my drink, right? But your drink is in terms of what? Volume. Okay, and what is this made up of? What material is this made up of? Maybe plastic, right? Okay, but it's your surface material lah. Okay, so when will it be cost effective? Okay, you think of it. What are you paying for when you produce this? You need what to produce this thing? Plastic, right? So you want to have more plastic or less plastic to be cost effective? Less, right? So the plastic forms your surface. What are we trying to do? We are trying to minimize your surface area. But at the same time, to hold more what? More content, right? More soup, right? More drink, right? So I want to maximize what? The volume. So my goal over here is to maximize volume, minimize surface area. Okay? So cost effectiveness, okay? You need to ask yourself now, what is the relationship of cost effectiveness? Okay? Now, when it comes to relationship, right, what topic talks about relationship? Your Sect 2. What you learn in Sect 2? What kind of relationship do we have? What is this? Yes, direct and inverse proportion, right? So you want your cost effectiveness to scale up with what? You want to hold more volume, right? So it must be directly proportional to your volume. Then do you expect your cost effectiveness to be directly proportional to surface area or inversely proportional? Inverse, right? Okay, you want to minimize surface area. Okay, your goal is to find the ratio of volume over surface area. Is that clear? Okay, now I use proportions to explain this concept, but you don't really need to come up with the what you call that, the very mathematical terms lah. It's just a concept. Okay, what I need you to walk away is that you want to have more volume but less materials. That's how you make it cost effective. Okay, so our goal is to find volume first. Okay, so first thing first, the information we have, right, is H1 over H2 is 4/9. Okay, from this, right, what can we find already? We can find what? The volume. Okay, so H1 over H2, right, cube will give me the V1 over V2, right? That will be then 16/81. Okay, that is my proportion for my volume first. But I need to find the exact volume, what? I cannot just anyhow find any random thing, what, right? So I need to do the following first. Okay, A1 over A2, okay, is equals to H1 over H2. Yes. Okay, that is what? Oh, Sorry. I think I did it wrongly. Sorry. Wait, my bad, my bad. Let me rewrite this. I meant to say A1 over A2, not V1 over V2. Sorry. Okay, but like that lah, this is correct. Okay. So now we find the ratio of the surface area here, right? Then we go back to what we have. The surface area of the small can is 240, which means this part is my 240. Agreed? Okay, my front row guys agree, right? Okay, because this one is my ratio of area, right? This part is my 240. Correct? Because I know my surface area of the small one is 240, so it belongs to A1. Okay, so then we can write 16 over 81, right, is equals to 240 over the, I don't know what is this guy, okay, the surface area of the large one. So therefore, SA large is 240 times 81 over 16. Okay, if you're wondering how I got this, escalator, this guy go up, this guy go up, this guy go down. Okay, like that. Okay, FA needs to go up, need to go to level 1, right? Then FA will be over here, the rest will go to the other side. So they must take the escalator to go to the other side. Make sense? Okay, so then this part you calculate already, right? You will have 1215. So now I have the actual area of the big can and the small can. Agreed? With that, we move on to the next part. We need to find volume. Okay, and volume, this one is 4 over 9 cube, then is 64 over 729. Okay, this one is correct already. And okay, so now we settle the volume part. But here's the thing, we don't actually know the actual volume, right? So we have no choice but to use the ratio. Okay, and that being said, we go back to what we are finding, cost effectiveness. Okay, we already have information on V1, V2. We already have information on the wait, on top or which one? Or the information, wait, what are you talking about? A1, A2. Why is it A1, A2? This is cube, okay. So A1, A2 is on top. I square already. Right? Below is cube. So I'm not finding area anymore. I'm finding volume. Make sense, Okay. So now I go back to this, right? I have information on V1, V2. I got information on your two surface area. So now my first ratio, right? Okay, I need to go back to what I'm finding. Okay, cost effectiveness. Okay, cost effectiveness of the small can, right, is V1 over the 240. Okay, and V1 is 64 over 240, which is approximately 0.267 units of soup per cm squared. Okay, if you're wondering what's going on over here, the soup is in volumes, the area is cm cube, cm squared. So you write it like this. Yeah. Can see? I can't scroll up anymore. I zoom out, can? Yeah. Okay, yes. Then I move on to the next part. Okay, cost effectiveness of big, right, would then be V2 over 1215, which is 729 over 1215. Okay, and then this will be equals to 0.6 unit soup per cm squared. Right, can see? Okay, let me push up for you a bit. Okay, wow. Better? Okay, can. 267. This one, right? Can. Okay, squared.
Wait, what do you write? Units of
Unit soup. Cause volume volume over soup Okay, if you don't want to write unit soup per cm squared, I think you can just leave it out lah. Okay, I think to save yourself from the trouble, you don't want to write it down, it's okay. Okay, but now you compare which one is more cost effective, small one or big one? Small one is 0.2, right? Then the small one is 0.6. So who is more cost effective? Huh? Oh, 可以，来 for tomorrow. Okay, bye bye. Okay, so 0.267 versus 0.6. Who is on, right? I remember it's on. I remember it's on. Okay, but which one is more cost effective? 0.267 or 0.6? 0.6 lah. So larger is better. Okay. Since it holds more soup with less materials. Okay? Don't need to copy everything. Just copy the keywords. Okay? So keywords like larger, better, more soup, less material. Enough. Don't need to write everything one. Okay? Just write the keywords. Okay? In the exam, then you vomit out all the keywords. Okay? So something about note taking, right? Don't copy everything. Copy the parts that you need. Okay? Chandran and Ryan can see already? Can Okay, I will leave this for a minute. Those who cannot see, please let me know. Okay? Zoom out. Zoom in. Those, wow, I hate it. You know why? Some say zoom in, some say zoom out. Okay, but I zoom in for you. Can see? Okay, come. Ryan still writing down? Okay, and Chandran still writing? Can see? Cannot see Cannot... Oh wow, okay, and okay. I think can. The more cost effective part again. Okay, then. So let me explain again. Now, if you want your material to be more cost effective, right? Do you want to have what do you need to have? You have volume and surface area, right? You want more volume or less volume? You want less surface area or more surface area? Right? So wouldn't it naturally be directly proportional to volume? Because cost effectiveness goes up when your volume goes up. So it's a direct relation, correct? But your surface area, you want it to be lesser so that your cost effectiveness goes up. That is inverse or direct? There you go lah. So because the layman terms for direct and inverse proportion is that direct, right? Both must go up or both must go down. For inverse, one up, one down. So once you have this already, right, you bomb the formula in. Okay, that's the general idea. Okay, but you must use a ratio lah. You cannot use anything else because if not, how are you going to compare? So for comparison, right, you usually use a ratio or a fraction. Okay, that is the best way to compare. You can't just tell me, I mean, yeah lah, there's no other way to compare lah. That's the best way to do it already. Okay? I answered the question already? Sick. Anyone else got any question? Because I'll be done with this topic already. Okay? No, Okay, can. Now, let's move on to mensuration. Now, originally, I wanted to go through some questions for this, right? But I think I'm not going to do it lah. Okay, because I don't have much time. I want to spend more time on graphs. Okay, let me ask, who hates graph? Okay, very good. Okay, I assume those who are online, you hate graph also. Okay, so I will not go through any questions for mensuration. I think you guys are not so bad. Okay, but I will just drop something. I look at last year's O-level questions, right? The mensuration question, right, is quite difficult. Okay, but don't worry, that one I think is less of a concern. That question only 4 marks only. Okay, but graph questions, right, is very common. So I need you all to sharpen up your skills for graphs. Okay, now for mensuration, let me ask you guys, any of your teachers tell you any hack or not for this topic? Did any of your teachers tell you there's a hidden formula in your formula sheet? Nobody, right? I think I got tell you, right? Okay, so For those in my regular class, you all will know that I got tell you this hack one. Okay, I think for Maya, I never tell you because our questions don't have mensuration yet. But next year, AMF will have mensuration. Okay, so I will just tell you something first. Okay, let's go to the next part. Okay, I will just open this diagram over here, a blank sheet. Okay, you all just take down from there. Okay, so what I'm going to do is to write one of the formula, right, that is inside a formula sheet. Guys, what is this? What is this? Like, this side over here, what is this? It's in a formula sheet. You all recognize this? Anybody recognize this or not? Say again? I heard pyramid and cone. Cone? What? Volume of cone. I heard pyramid and cone. Okay. So this is the volume of cone, right? Okay. And from here, right? If I take out the 1/3, what is this? What is this, guys? Volume of cylinder. Okay. So let's write this part down first. This part is your volume of cylinder. Is it in your formula sheet? Is it in your formula sheet? Yes. You just cover the 1/3 can already. Not wrong, right? Okay, I draw the cylinder for you guys. Guys, this is the hidden formula for cylinder. Okay, if you draw the cylinder, right, this is actually what kind of shape? It's an upgraded prism. Okay, and to identify a prism, right, you always look for the two sides which are opposite and equal. Okay, because that is how you tell what your base is, right? Sarah, can you got here right there? Okay, so for prism, right, or for cylinders, right, always look for what is opposite and equal. So obviously your base area is what? What shape is your base area? What shape is the same base? What's the base of the shape? Circle. Okay, and once again, guys, let me unravel one more formula. Those who still don't know what a circle formula is, right? It's over here. Area of circle. You don't know this, right? Now you know. Okay, so this is the formula for circle. Okay, now I'm going to do a bit of reverse engineering. Okay, since this is the area of a circle, right? If I replace this with AH, right? What formula is this? What is this? Nobody know what is this. Okay, base area, right, times height, right? When it's 1/3, you will connect the top, the apex to this. What shape is that? Pyramid. This is the volume of pyramid. Okay, so you only need to replace the pi r square, right, with a general area. Usually it will be a square base. Okay, so for example, okay, 1/3 base times length times base, right, times height. Okay, so this is assuming it's a square base. Okay, which is over here or a rectangular base, for example. Okay, so once again, another hidden formula, right? You can replace your A with any base area, whatever you want. It can even be a triangle. Okay, but triangle a bit difficult That one you need to use a bit of Pythagoras theorem. Okay, so what else can we infer? If we take out the 1/3, we cover the 1/3. What do we have? What's AH? Okay, go back to your cylinder. Your cylinder, right, is pi r square h. If I replace the pi r square with area, right, what does it become? I just change the circle, right, into something like a triangle, right? What shape is this, guys? What is this? Prism. Thank you. So same thing. AH. Find the base area and then find the height. That's it. You got the volume of prism already. Very fast. All this formula, right, is hidden. Okay, so now you know okay. Anything else to know? I think no more already Okay. For trapezium and pyramid, I think that one a bit more obvious Your teachers might have told you this. Okay. But for pyramid, right, your formula for area is AH. Okay. Now, the A is the area. The A is the, sorry, not the same, not the same. Okay, small a and h. Okay, so for example, this is your A, right? Your h is the vertical, your perpendicular lah, right? Now, what formula is similar to this? What requires perpendicular height? What shape requires perpendicular height? Sorry, something angle? No need to be right angle. As long as it's a triangle, can already. Okay, because your height is the perpendicular to the base. Correct? So that's why this formula is so similar to your parallelogram. Okay, and how I tell people, right, is that if you treat this triangle, right, you shift it over here. What does it become? It becomes a what shape? Okay, you cut this. Let's imagine you cut this part, right, and you bring over to the other side. What do you get? Rectangle. Okay, A times H. Okay, last but not least, your trapezium. Okay, how many of y'all cannot remember trapezium formula? Quite a few. Okay, so let me just highlight this again. Now, when you have trapezium, always got parallel sides, right? Okay, on top is A, below is B, right? And then you got your perpendicular height. Now, how I teach this one? Very simple. Always cut this into a triangle, right? And what do y'all get? Y'all get the on top triangle, y'all get the below triangle, right? And what is the on top? This is A, right? The below one is B, right? And they have the same height. Correct or not? They have the same height, right? Everybody agree? All agree, yeah? So what's the area of the bottom triangle? Half times. What's the base? On top one is, okay, the below one is B, right? What's the height? H. This triangle over here, what's the area? Half times. So you add up together, what do you get? Half A plus B times H. Okay, so this is one way to remember your trapezium and your parallelogram lah. The rest is quite easy to do, so I won't go through that one. Okay, so that is the general tip for mensuration. Any questions? Yes. Oh, this one rectangular base. Okay, rectangular base Okay, you want me to spell? I spell out for you. Nah, it's okay. Okay, rectangular base Okay. Can everyone see? Need to take down anything or take photo? Okay, at least for 30 seconds I think take photo better lah. Okay, just take photo better. Don't write down very long. Okay, I will move on to graphs. Okay, so once you're done with this already, right? I'll move on to graphs. You need a pencil? You have? Oh, okay, can already Okay, the rest, everyone okay? Yes, someone say something? Someone need something? No, okay, can. All right. Let's move on to the last part of this session. Okay, so the remaining 45 minutes, right? I will drill you guys on graphs. Okay, so let's skip all of these things. Okay, now, this is your graphs. Now, I know some of you guys are not very good at graphs. Okay, so here's how it works. Now, in Sec 1, what kind of graphs do y'all learn? Linear, right? So we look at the easiest one. Okay, linear graph means what? Horizontal line, right? No x, only got y. Okay, so when y is equals to a, okay, this is page 42. Okay, everyone flip to page 42. Okay, everyone at page 42 already. Okay, now for the first one over here, y equals to a, right, means I have a horizontal line. Okay, what does y equals to a means? It means it crosses the y-axis. That's why it starts with y. Correct? Make sense? So I draw a horizontal line, right, that passes through, right? When my y is 1 and 0, means it's above the, what is this? X-axis. So it's above, okay, it's above. Now, if it's below, then it will be the other side. Okay, it will be below. Okay, so this is a more, salah. Okay, a more than 0, a less than 0. Okay, So this one is for x power 0, because it doesn't depend on x. So it's just a straight horizontal line. Okay? Now, this one very straightforward. Let's move back to the previous page. Okay, later I'll make you all move again. Okay, let's Uno reverse back to over here. Okay, so this one over here, we have a linear graph. But this time around, what features did we add? Previously, the graph only got y-intercept, right? Now got what? X-intercept. What else? Okay, yes, it cuts the origin, right? But more importantly, it now has a gradient. Okay, and the gradient is your A. Okay, so your A, right, can be treated as difficulty in climbing. Okay. So you see, when it comes to difficulty in climbing, right? Okay, you need to ask yourself, are you focused with going forward or going up and down? You rank your difficulty, right? Will you rank in terms of going straight or going up or down? Up, right? Up and down is more difficult, right? So if your A is bigger, you will expect that your gradient is steeper. It will be more difficult to climb up. Whereas on the other hand, when you're going down, right, it's very easy to slide down. Okay, so this one, difficult to climb, easy to slide. What if the gradient is infinity? Then you just fall to death lah. Boom, finish. Okay, so this is one way you can use to remember this. Okay, but if you are familiar with linear graph, this should be fine lah. Okay, now let's move on to on top. This is a quadratic. It's written in the form of ax squared, ax squared. Okay, so this one I think you all should know lah. Okay, what do you all learn in school? Happy face, sad face. Okay, have you all heard of happy face, sad face? F, right? Okay, so for the first one, happy face, like that. Okay, so when your A is positive, right, you'll be happy. Cause why? A, you can think of it as money. I give you more money, you'll be happier or sad? Happy, right? If I give you a lot of money, right, wow, your graph will be very steep. Okay, so it's directly proportional to your how much money I give you. Okay, if you are like the Squid Game guy, won the whole game, wow, this guy will be very happy, very, very happy. But no lah, in the show he's quite sad lah, because his comrades all die. Okay, so you look at the other guy. Instead, I don't give you money, I take money from you. Happy or not? No lah, of course not happy lah. I take money from you, you come out angry at me, what? So the more money I take from you, the angrier you'll become. So sad face. Maybe you put you put an eye, right, and then you put this. Wow, it's not really angry. Okay. Okay, so that is your happy face and your sad face. Yes.
For the sad face graph, A less than.
Did I write anything? Never write anything, right? Yeah. A less than 0. Okay, can. Now let's move on to the next part. For cubic equations, right? This one, you compare it to your linear graph, but the shape is like a chair. Okay, what do I mean? So your chair, right, usually is like that. You got a leg over here, you got a leg over here, right? So it's either your chair facing this way or your chair facing the other way, right? So for the first one, okay, and why is chair? Because C stands for chair. That's why it looks like a chair, So your chair, like that. If it's going up this way, it will be positive. It's similar to your line graph. You go up, you'll be happy, you'll be more difficult to come up, right? And on the other hand, negative, you go down. Okay? So, for the first one, your chair will be going upwards. Your second one, your chair will be going downwards. So, once again, ax cubed, A more than 0. Ax cubed, A less than 0. Okay? Quite no-brainer, right? Long, I did there already, A less than 0, okay, basically it depends on how you define. Okay, you need to know A is an unknown. So you will only put a negative, let's say if you have an actual example like 2x cubed or you got negative 2x cubed, then you will see a negative. But right now our unknown, right, which is A, right, can be positive or negative. So that's why I separate into A more than 0, A less than 0. Does that make sense? But you are right lah, because it's the way we define it lah. Okay, but you just need to know the general idea. That's enough already. Okay? Can? Back row, okay? Steady, ah. Okay, yeah, nice. Okay, let's move on to the next part. Okay? Reciprocal. Okay, so we go to this part, Now, guys, reciprocal, right? I teach you a very simple way. Okay? When do you see y equals to 1 over x? When do you see this before? Any idea? What else? In Sept 2, have you seen this before? Think again. Confirm have one. Yes. What kind of proportion? Inverse. How do you draw your inverse proportion? And your axis is like that, right? Okay? So, no? Vomit out, come out already. Never think of this, right? But then, there's an additional catch. Your graph can also be negative. Correct? So you need to ask yourself, right? If x is less than 0, right, your y should be less than 0. Okay, why? Because if your fraction is negative, obviously your y is negative, what? Right? So you will need to duplicate the side on the negative portion. Okay, negative x and negative y portion. Okay, so you need to draw a boomerang on both sides, like this. Does that make sense? Okay, and then for the other part over here, you just need to flip it. Right? Because why? If you have y equals to negative 1 over x, right? When x is negative, or rather when x is positive, right? Y is, thank you, y is negative. So in this case, you will draw on plus y minus x kind of side. Okay, so the only way you will have this is this part or this part. Okay, basically the axis must be alternating lah. Okay, if you are looking at positive y, you will look at negative x. So you will draw your reciprocal graph, right, as such in those two quadrants. Okay, now for the next one over here, this one over here, okay, it will be both go up, both go down. Basically, the idea is this: when you have y equals to 1 over x squared, right? Okay, when x is positive, what's my y? Okay, when x is negative, right? You square a negative number, right? Will it ever be positive or negative? Positive, right? You square a negative is always positive one. So when x is more than 0, y is more than 0. Correct or not? But here's the thing. When x is less than 0, y is also more than 0, what? Because you square negative, you can be positive. So no matter what value of x this is, it will always be above the graph. For this same reason, if you have the other side, y equals to negative 1 over x, right? Squared, you flip it downwards. That's it. Okay? The graph, right, is always going to be similar to the power negative 1. Okay? The structure is the same. Okay? And Annabelle, okay? Can I know your names. Okay? Can. Good. Can I move on? You need to take photo? Anything? Okay, the last one over here. Okay, next part. Okay, hang in there. Almost there. Okay. Now this one over here. I think I teach you this before, right? Guys, all take out your right hand. All take out your right hand. Okay, look at your right hand. Okay, what do y'all see? Okay, do y'all see this or not? Y'all have this? Have or not? Yes, right. Okay, so this part over here. Okay, now let me just draw below in this space. Okay, this part, okay, on the right hand side, right? Are you okay? Yeah. Okay, you draw this right over here, right? This hand over here will have my axis come out like this. Okay, so this is my a to the power of x. Sorry, a. Let me see. This is my k a x. Okay, my exponential graph, right? Okay, this form is a k a x, right? And it will be going up as per normal. This is my x-axis, right? And my right hand is on the right side of the axis. Therefore, I will draw on the right side, Then if on the left side, right, I use what hand? Right side, I use right hand. Left side, I use what hand? Huh? Left hand, right? So left hand, once again, I see this. Okay, all take a look. My left hand got this thing over here. Okay, can see it or not? Okay, so you draw according to this. Okay, wrong. Okay, so this is my KA negative X because I'm in the negative X region. Okay, I replace it with negative X. Can? Then after that, for the below part, right? Since you know you flip this way already, right? Okay, you flip this way. Now you just need to flip downwards like this. So that one very easy, You just need to flip. You will get this, and you will get this. Okay? Why? What happened? Look very ugly, Yeah, draw again. I draw again. Okay, so generally you use your hands, right? Okay, you use your palms and all that, right? You will get all these four shapes. Okay? And for AMF, you all should know that this applies also, right? You use this for your AMF as well. Okay, your AMF also got logarithm, also got logarithms. Okay, come. Some time to let you all see, internalize, then we move on. Too cold, Sure, no problem. Okay, let's take another break first. I think everyone's very tired. Yeah, break. Okay, I give you a 5 minutes break again. Okay, you come back in a while. Hey, very low already, leh. Okay, already. Wait, Okay? Come out again, I just realized your Okay. Yes. So, so this is easy for you, for you, but how is it for you? Easy for you. Sorry, that's like that. So you need to rest. But I appreciate it. You got a lot of questions to do now, so forget. I mean, it's too tired for him. Yeah, you just see what is best for you. How are you guys doing? You're very happy, Online guys, any questions or not? If you have, you'll just type in the chat. I said, is this boring for you? So, what's your biggest topic after going through all this, after all these questions? Okay, and Sarah, what were you doing? Go study, Yeah. So, we are all subject head of certain things. Hey, why you answer? He very clear. Hey, you know him, oh, you see them, oh, you think it's clear, am I clear? I can put that, you want me to what? You see my second class, you see my second students, that class I cannot clear, okay, boy. Come on, this one. Okay, right? Right now here. The picture okay? Yeah, you will need two for you, right? One no one day anything. Huh? Okay, don't lah. How to do? Okay. I'm very tired. I want to sleep already. Tomorrow still got another 6 hour class. That day I got another 6 hours. Thursday I got another 4 hours. Another 5 hours. No. I don't. Next year, yes. You're not in AMF or you got no AMF, right? Huh? I asked you, don't have I just guess lah. There's something on Wait, then you say you're in level class? On Friday, You? But oh yeah, I can But you stay near here or here? I teach event but I will most likely be at Emily. But this year, your current October lah. But this year, this October, correct? Oh. What? Like. You never tell me what? You just say. Next year my EMF will be at Japanese Golf. That's the only EMF I have lah. Sept 4, right? Friday. There's always online. Okay, no one's here already, right? I can don't bother to do Okay, come, guys. Last half an hour to go, Okay. Bear with me. I think maybe not half an hour lah, but I'll try to be fast lah. Okay. So for kinematics, right? This one, this is your distance time graph, your speed time graph, right? Okay. This part, okay, I will not go through this part. I will go through in the examples because I need you to see how I do it, rather than I explain all this to you all. You all won't get it one. Okay. Now let's take a look at the graph over here. Okay. Where's my pen? Oh, it's here. Okay, come. Do I need my charger? Yes, I think I need my charger. Let me charge my iPad first. Okay, yay, charging. Okay, now let's sketch the graph in the spaces below. So we see y equal to 4 over x, right? What kind of graph should we see? Can you go and try out first? 30 seconds. Draw out. 27, 35, 34, 22.5. Okay, go and draw out the graph first. Try part A and part B. Okay? Then get refer This one looks like what? What kind of graph? Your proportions, right? You know the draw proportions, right? You draw that one, right? What we write is your proportion is always like that, okay? That is the other opposite. Make sure you draw both sides, Don't only draw one side, Okay? Come. Done already not? Don't know how to draw. Draw already. Let me see. I cannot see. Okay, okay, very good. Okay, very good. This is okay, but must pass through what? The original. That's correct. Okay, yes. Very good. That's okay. What's this? The box. Pass through one. Okay, correct. Yes. Okay. Must try to go and remember how to do it. Okay, exam you got no graph for you one. Well, intersect or not? Does it have a plus C or not? No, then it pass through origin. Let me explain that one later. Okay, this right, I want to see all your graph. I haven't seen it. Okay, so that's yes, very good. Yes. Okay, yes. Yeah. What's it? Sorry. It's correct. It's correct. Place but very good. Move of it. Now draw like a curve. Like see how? Oh, quite nice. Yes, your bottom one. Don't know. You looking? You can look or not? Can. Bro. Okay, my online guys, you all done already? Everyone okay? Okay, for the first one, y equal to x over 4. What kind of graph should I draw? My inverse proportion, right? Like that. Okay, so let's can see not. It's like that, smooth down. Like you take a slide, go down like that. Okay, I don't see these cannot Okay, for the rest, I got see some of you like that also Okay, now this one where do you all draw the rest of it? Opposite, very good. Okay, like that. Now, this 4 over here, right, is a distraction. Don't let it affect you. Okay? Now, over here, right, some of your -2. This one is y-intercept. So I draw over here. Correct or wrong? No. Okay? This is not your y-intercept. Why? Okay? Because when x equal to 0, right, what is my y? You sub in x equal to 0, what's my y? So it passes through the origin. Okay? And now, this negative, right, tells me, right, is it this chair or is it the second chair? Second chair, it's a going down one, right? So your graph will look like this. Oh no. Okay, like that. Okay, this is the graph I should see. Yes. Why? You don't like my graph? I draw very nice already. Okay, can So this is the graph you're supposed to have. I do not want to see people draw like that Wrong Okay? Like that is correct. Okay? Okay, so hence, state the number of solutions for the equation 4 over x plus 2x cubed equal to 0. Okay, so this one, right, you take a look. You think what intercept or not? Okay, before we go there, how to solve for this one? Whenever you are given this, right, you need to do what? Relate this to the graph that you already draw before. Okay, so ask yourself, I have 4 over x, right? It's the first one. Okay, and I also have 2x cubed over here, right? So what I need to do, I need to separate them out so that I get 4 over x equals to negative 2x cubed. So this is my first graph, this is my second graph. So you just imagine, this guy go up. Do they intersect or not? Does this graph intersect with this graph or not? No. So therefore, no solution. Finish. One line only. Okay? Number of solution, no solution. Okay? Because it's like water passing through a river. Right? make the what? Colder? Wow, some say hot, some say cold, yeah. I think it's not a fan. Okay, back row, let me know if it's too cold. Okay, I do the intermediate already. Midpoint of 23 and 25. What is the lesson? Thank you very much. Okay, clap for him. Okay, just kidding. Okay, thank you. Hey, now I very hot also. Okay, so now let's move on to the next question. Okay, now from the graph below, right, choose one that represents the best out of all of them. Okay, so for this one, right, very simple. Look over here. Y equals to 3 over x squared, right? Okay, from this graph, right, do you all think I will ever have a y-intercept or not? Or rather an origin? No, right? No origin, no intercept. So graph 1 and 6 is out already. Okay, what else? Below is x squared, right? So should I have both on the same side, on top, or both opposite side? So what do I mean? Should I have like this or like this? Which is more probable? Which is more likely to be the case? On top or below? On top, right? So all those graphs that is terbalik one, wrong. I only left with 4 and 2, right? The next question is, should it be both on top or both below? On top, why? The coefficient is positive. So the answer is graph 4. Eh? Yeah, graph 4 is correct. Okay, can? So this one is a no-brainer one, quite easy to do. Okay, if you're very scared, right? If you're not very sure what to do, right? Okay, listen up. If you don't know what to do, just sub in some values and go and plot. But that one take a lot of time, so I don't encourage it. So unless you're very desperate, then you do that. Okay, now the next one over here, y equals to negative 4 over x. Immediately, what kind of graph should we be looking at? The opposite one, right? So 1, 2, 4, 6 out already. Your focus is on 3 and 5. Now, this one, right, should it be 3 or 5? Why? Because it's negative, right? So the standard one, right, is your online guys, right? Can you hear me or not? Please give me an indication you can hear me. Okay, can. Okay, can. So all can hear me, Okay. Sorry, settled already. Now, negative 4 over x, right? Your standard graph should be like this, right? This is your original graph, right? Your inverse proportion. Okay? But it is on the positive x and the positive 1 side. If you have negative, right, will it still be the same position? No. So therefore, graph 3, graph 5 is also out. Your answer is graph 3. Okay? Can? Last but not least, okay, for the last one, 3y equals to x cubed minus 9. Now, what kind of graph is this? What kind of graph is this? Cubic is power 3, right? Can you see there's a power 3 over here? Okay, so this tells me that 2, 3, 4, 5 is out already. Okay, then the next thing to ask myself, right, is how do I know it's 1 or 6? Which one? Arisa, you want to say something? Okay. Like that, right? And so? You can find the what again? Ax cubed, Okay. Yeah, basically telling me which shape looks more appropriate, right? So your answer is very good. Okay, let me explain to you what she said. Okay, if I understand correctly, okay, you can correct me. So first thing first, the y-intercept is what? -3. So both of them are below. So you can't tell apart whether it's the first one or sixth one based on the y-intercept. What you should know is that this is a transformation of the graph x cubed over 3. Do you all know the graph for x cubed over 3? What shape is that? The chair, right? And this chair is the positive one, right? So when you shift down by 3, right, all you are doing is moving downwards by 3. So therefore, the answer is 6. Are you started? I explained correctly? Okay, so this is the logic. Okay, how you tell whether it's 1 or 6, right? It's really just based on do you know your shape well. Okay, it cannot be 1 because your x cubed, right, over 3, right, is supposed to look like 6. It's supposed to look like a chair. It's not supposed to look like a my back will pain. My back will break, so I can't do that. Okay, but basically cannot be like that lah. Okay, so answer is 6. Any questions? No? Let's move on to the last part. Okay, no one need to take down anything, right, for this part? No, so this one is just a matter of logic and knowing your graphs well. Okay, now this question I will skip because I think it's not worth my time teaching this. But this is like everybody's work, this paper, right? This is actually okay, right? So the one you all don't like is the speed time graph one, right? Okay, can. Let me go through that one. Now, speed time graph, I want to do it this way. Okay, let's use once again a new page. Okay. Disclaimer, right? I may overrun for sure. Okay, because I want to deliver the best I can. So if you all need to go off, it will be recorded. Don't worry. We will upload the recording. Okay, now this one, let's talk about. Okay, I tell you what, we do example easier. Okay, so move on to page question number 4. Okay, let's look at this over here. We will do calculation first. Okay, then we move on to drawing graph. Okay, so first thing first. Okay, the diagram shows the speed time graph of motorist journey. What kind of graph it is? Speed time, distance time, or acceleration time? Speed time, right? Okay, so this one over here, speed and time. Okay, one thing I need you to know, okay, SVA. Okay, not SBA, DBA. Okay, because I realize you don't take AMAth, right? Or rather, it's a tech 4 topic. Okay, so DBA, right, is distance. Okay, never mind, DSA. Okay, let's use DSA. Okay, so DSA is distance, speed, and acceleration. You know what's DSA, right? Direct school admission. Very good. DSA, direct school admission. So, from speed to distance, right, okay, is area. From speed to acceleration is gradient. Okay, this one you must know.
What do you mean? And what do you mean distance and speed?
I will show you in this question. Okay, so find the acceleration of the motorist in the first 10 seconds. Now, why is the gradient referring to acceleration? Let's take a look. Okay, acceleration, right, is meter per second what? Square, right? Velocity is what? Meter per second power of -1, right? So what happened? You divide by s, right? So am I right to say that your acceleration is your change in your speed over change in your time? Isn't this gradient? That's why I say Vs go to A, right, is gradient. Okay? So to find the acceleration in the first 10 seconds, right, you look at the graph for the first 10 seconds. Okay? Is the acceleration constant? Yes, right? Because your gradient is constant. It's a linear graph. Your gradient will be constant. So to find the gradient, right, you need to know 2 points. Okay? And from here, simple. We put 40. Okay, on top, right, is 10, 40. Below is 0, 0, right? So we will have 40 minus 0, 10 minus 0. Answer is 4 meter per second squared. Okay, like this. Some of you put 4m slash 2 squared, right? Okay, whichever you prefer lah. Can see or not? You need me zoom in or zoom out? Like that hand? Can Okay, like that hand? Okay, so this is for your part A. Very simple one. Okay, then after that they tell you, find the speed of the motorist at the 6th second. Now, where is the 6 second? It's between 0 and 10. So my speed is over here. Okay? If I know that this is 6, right? What do I need to know? So this one, the analogy is that when it comes to coordinates, when you know that x is 6, right? You must always have a what? Y, right? So it's like a boyfriend and a girlfriend together. Your coordinate is boyfriend, girlfriend. Okay? So you must know, if you know the boyfriend, you must know who's the girlfriend, right? So if I know that this is 6, right? I need to know who's my y. And what better way to do this than to use your... Use what? Area? Why use area? Do you know anything about the area or not? But do you know the proportions? No, so cannot lah. The only way to use is ask yourself, does this have the same acceleration? Yes. Because it's the same gradient. Same gradient means same acceleration. Correct? So you will use the answer from part A. 4 is equals to the change in your on top over the change in the bottom. So in this case, your unknown is V, right? So let's use 6 comma V. In this case, I will put V minus 0. Okay, I'll compare the on top coordinate with the origin. Make your life easy. Okay, some of you will ask me, sure, can you use 10 comma 40 or not? Can lah, but a bit harder lah. You got origin, why don't I use origin? Okay, so for the next part over here, right? Okay, V minus 0 over 6 minus 0. From there, you work your way backwards, right? V is 24 meter per second. That's it. Okay? Very simple, right? Okay, and last but not least, this part is your distance time graph already, right? So let's explore what is going on over here. Okay, so let me explain. Now, when your velocity is high, right, your distance covered will be more, right? Agreed? If your speed is low, your speed is high, you will cover more distance. If your speed is low, how much distance will you cover? More or less? Less, right? So the easiest way to explain this is you imagine I draw rectangles like that. Okay, so these rectangles, right, represents, right, the distance that I covered. So if my speed is like this, right, my distance will be this small rectangle, correct? But the more the speed is, right, the more distance I will cover. And that is well explained by the area under the graph. Okay, so how do you find the distance? You add them up progressively. So initially, you add a little bit of distance. But as you add more and more, your distance will increase more than proportionate or less than proportionate. More. You see, you are adding this plus this plus this plus this, right? Wouldn't it get more and more and more? Right? Compared to when you add this plus this plus this. Which one got more? On top or below? On top, right? So naturally, my graph will be more than proportionate. Like this. Okay, it will be a curve that is going upwards. Okay? So I hope yours is. -1. Yeah. Indices. If you want, you can put 24m/s. Also can. Okay, now once you all reach here already, right? The next thing is my distance covered when my speed is 40 my speed is 40 meters per second, right? Every second, my distance, right? I add the same rectangle or I add a larger rectangle. Same, right? So that means to say, my next distance is going to be a straight line upwards. Okay, this part must be smooth lah. I need this part to be smooth. Okay, so try your best to make this as smooth as you can. Okay, when I give you the answer key later on, right? The answer key for the next question will not be smooth one, but I just warn you all first. Okay, that one is the answer key from the school. So what you should have is a smooth line like this. Okay, because cannot be your distance suddenly shoot up or shoot down correct? It must be smooth. Okay, where got your car you drive, right? Suddenly you stop, right? You slow down, right? Your distance will like that drop down. Cannot be what, right? It must be a smooth decrease or smooth increase in that sense. Okay, so that's it for this question. Any questions? No, okay, let's move on. Okay, ideally, I want to go through one more question. Okay, then we call it a day already, Now, the speed time graph of ABCD below shows the movement of a particle in 7 seconds. Okay, sketch the corresponding distance time graph of the particle, indicate the vertical axis clearly. So this one is distance, right? So I'm finding area or gradient. Area. So for the first one, right? I start from where do I start from? I start from the axis, right? From the origin, right? Because I don't know my distance, haven't calculated anything yet, right? Even though my speed is 10, I haven't really calculated my distance yet. So I must start from 0 first. Does that make sense? Y'all don't look very convinced. Okay, because okay, you just imagine I'm driving in the middle of the road, right? But I haven't started my timer. Have I counted the distance yet? Haven't, right? So only when I start the timer, then I count the distance. Does that make sense? Okay, so now, you see, my speed is decreasing. So at first, I cover more than I cover a lot of distance, right? But as I slow down, will I cover more than proportionate or less than proportionate? Sorry? You see, my speed is decreasing, right? So every unit, the distance I cover, right, will it be more or less? Less. Okay, so you just imagine I add the same rectangles, right? At first, I got very big rectangle. Then I add lesser and lesser and lesser. So it should be a less than proportionate increase, like this. Okay, is it like that? Yeah, correct. Okay, so it's supposed to be like this. Can? So compared to just now, it's a more than proportionate increase, right? This one is less than proportionate. Then in the next 2 seconds, right, my speed is the same. So do I cover more than proportionate, less than proportionate, or same proportion of distance? Wow, very confident, very good. I like. So hum thumb a straight line forward. Then last but not least, now your speed starting to pick up. Will you move more than proportionate or less than proportionate now? Now your speed increase already, right? You cover more, right? So instinct one. This kind of thing is instinct. So my graph will be like that. Okay, that's my answer. Then I need to have the relevant values, right? Okay, so all these things over here are your distance. In order to find the distance, right, you need to go back to your area under graph, right? So for this first part over here, I need to calculate this distance, or rather this area, right? How to find this area? What shape is this? Trapezium. So I just need to know the two parallel sides. Okay, this is 10, this is 4. The height is 1, right? So half times 10 plus 4 times 1. That is my first part, right? This is equal to 7. So my first distance is 7. Agreed? Okay? Then the next part over here, this shape is what shape? From 1 to 3 seconds, what shape is that? Rectangle, right? So this one is just 2 times 4, 8. So guys, ask yourself, is this 0.8 or is it plus 8? Plus 8, I am increasing my speed, my distance based on the previous distance. So it's 15. Then this part over here is another trapezium, right? Now, if you don't like to calculate trapezium, you can always do triangle and rectangle, right? So this rectangle over here, right, is 4 times 4, 16. This triangle is half times 4 times 8. So this will give me 16 as well. So total is 32. 32 plus 15, 47. Finish. Okay? Anybody need me to repeat again? Oh, there's some questions over here. Sorry. Let me check. Can you use the physics formula for part A or will I get marked down? Cannot. You do not use physics formula over here. This is math, not physics. Okay. Yeah, I answered both already. Okay, so Kieran, I hope I answered your question. Physics formula is not applicable for E-math, for A-math. You for this question, okay? You can use it as a side working, you cannot use it as an actual working. Clear? Actually, physics formula is what? It's the same thing, what? Oh, that one, I don't think you can use that. But that is your gradient one. So you write it as a gradient formula, can. Don't write it as a physics formula. Yes. 78. This one. 47. Plus 32, right? Okay, can Okay, let's move on to the next square. Okay, never mind, let me copy first. Okay, I'm almost done. Almost done. Okay, I will go through one more part and I will call it a day already. Okay, I know you're very tired. Okay, I'm also very tired. Tomorrow was 6 more hours. Okay, so let's hang in there. Almost there already. Almost there already. Okay, shall we? Let's move on. Last part. Okay, now sketch the corresponding acceleration time graph of the particle. So let's go back to this. Okay, I'm going to copy down this part, bring to the other side. Take screenshot, copy, and like that. Okay. Now, guys, ask yourself, acceleration is what with respect to the velocity with the speed. Okay, if the distance is the area under graph of the velocity of the speed time graph, right? What is your distance? What is your acceleration time graph with respect to the speed? Gradient. So you need to ask yourself, right? The first one, gradient, is it constant? Okay, your gradient is constant, right? So acceleration is equal to gradient of speed. Agreed? So for the first part, right, my gradient is this part over here. Okay, is over here. Can see or not? This purple color part, is this gradient constant? It's a linear graph, right? So it's constant, right? So your acceleration is also constant. So you expect to draw a straight line. Okay, but this gradient over here, right, is negative, right? Correct? So I will draw a line below. Can see? I will draw a line below over here. Okay, over here, can see? Okay, can Then now, my gradient for the next one, right? B to C. Okay, what is my gradient? 0. So where my line supposed to be? Along the x-axis. So like that. Okay, can see? Let me highlight this part over here for you so you can see easily. Okay, for this part over here, the gradient is 0. So the acceleration is 0. Therefore, acceleration is equal to 0, right? This is just your horizontal line graph that passes through the x-axis. Correct? Last but not least, your gradient for the next one, is it positive or negative? Okay, is it constant? Constant, right? So your gradient for that one is like that. Can? That's it. Okay, but then you need to calculate the values, right? You need to indicate your values. So do ensure that you calculate your gradient. So for this one, the gradient is okay. On top here is 0, salah. Okay, on top here is 0, 10, right? Below is 1, 0. So the gradient is just am I right? No, right? The first one is what? 0, 10 is correct, right? The below one is what? 1, 4. Thank you. So the gradient is 10 minus 4 over 1 minus 0, right? Wrong. Is it tired already? Okay, 10 minus 4 over 0 minus 1. Answer is negative 6. Alright? So this is negative 6. Okay, the first one, the middle one is 0, right? Obviously. The last one is over here. Your on top is 7, 12. Below is very hot. 3, 1. Okay, so your gradient is just 12 minus 1, 7 minus 3, right? What do you get? Okay. Yeah. What kind of thing is 1? So it's 8 over 4 equals to 2. Okay, so the gradient is 2. Which means your that one shouldn't be so high. It should be a bit lower. But never mind. You just take note, can already. Okay, just take a mental note, can already. Okay? Just take a mental note, can already, so don't need to go and redraw. Okay, but the idea is that make sure that you calculate first before you draw out. What I was trying to show you is how to figure out where you should draw. Okay? Now, there's a part C, There's a part C, There's a part C, guys. Okay, so for part D, okay, find the average speed of the particle. Okay, average speed is what, guys? What's the formula for average speed? Very good. Total speed. Tired already, right? I also tired already. Okay, so total distance over total time. Okay, good. Now, total distance is what? We have it in the previous question, right? 47. What's my total time? 7. Answer 6.71 meter per second. Correct, 6.71. Okay, again. So now, before I end off, okay, I must of course tell myself a bit, ma. Okay, so let you all take this down first. Okay, while you are copying down, let me just do a bit of closing address. Okay, I don't want to hold you back already, but let me just close out a little bit. Okay. Okay, so I hope you all like my lesson. Seriously. Okay. I know it's very tiring. It's 10 p.m. already. Okay. I also want to go home. Okay. Well, those who stay not near temporary very shack, yeah. Okay, but before I let you all go off, okay. Okay, let me just do a bit of selling first, okay. So of course, some of you will be already asking me, right? Next year, am I teaching? Okay, yes, of course, I'm teaching next year, okay. So if you all were to sign up with us, okay, you all will get the following benefit, okay. So you all will have some created notes, and of course, you do some practice, For my class, right? For those who are my students, you all know I burn my ass off for you guys, okay. I write notes, write summary, write all kind of things, until I fall across sleep, okay. So I think you all don't not interested in this one, but if you all like the lesson, right, can go and scan, go and give Google review, give out full scan paper. Anyone interested? No, yes, okay, scan off. I will leave it later on for you guys. Okay, now, next year, I have a few classes, wait, I finishing already, Okay, come. Let me finish first, Okay, next year, I have a 2026 set of classes, okay? I have Sec 4 classes as well, A-Math and E-Math. Okay, for the A-Math guys, you all hear me again. So basically, if you all were to sign up, okay, you can, there's this part where you all can log in your interest first. So you can just take this QR code first, or go and scan first. Okay, online people also go and scan first. Okay, go and scan first. Those who are, if there's any Sec 4 over here, you don't need to do this, but unless you're doing H2 math next year, Okay, so of course there are other subjects, but if you sign up with us, right, okay, you will get this thing called an e-voucher, e-cashback. Okay, so it will waive off your fees for the next few terms, Okay, and then the registration fee, right, will also be waived off for you guys if you log in your registration. Now, when I say log in, doesn't mean you must commit. It just means you just indicate your interest. Whether you want or not, never mind. You can always think about it later. Okay, but at least you log in your interest first, right? Then we will ask you again, you want to sign up or not? Okay, then of course we have curated notes. Okay, early bird, I think got a few curated notes you can take one for free one. Okay, other than math, let's say you sign with me for math, right? You will get other subjects. Okay, so you don't need to know this. Okay, now for all of you, this is Sec 3 E-Math answer. Or take this down online also. I will leave this for 1 minute. If cannot see, let me know. Okay, can. You today everything cannot see. Next lesson you see in front again. Steady. You going for A-Math, right? Okay, you see in front next lesson. Can. Okay. The rest, anyone need help to take? Shit. Wait, let me try. Okay, I think I need to make it bigger at home. I cannot. Okay, can. Come.
No, it's good. It's good.
No, he needs to use also. Okay? Almost there. Okay, almost there. Okay, anyone else need more time to scan online also? No, Okay, can. Now, let me show you my classes next year. Okay, take photo also. Okay, these are my next year classes. What? Why? Okay, I'll see. Okay, wait. Sure. Hey, bye. See you. Yes. I will show this again. Don't worry. Okay, so for the rest, right? These are my classes for next year. This year don't bother lah. The year gonna end already lah. Okay, so for next year, right? Okay, those who need to go, you can go first, I think. Okay, but these are our classes for next year. Okay, you should be looking at the last few parts. Okay, for those who want Tech 4 A math, right? I have A math. For E math, I only got Japanese. Okay, yeah. So these are my classes. If you are interested, right? There are some other classes as well. You can go and scan this QR code. Okay, if not, I think that's it. Okay, so for those who want the like really lah, unless you want full scale paper or ask me questions. Okay, so if you all want anything, okay, you all just stay back. The rest can go already. Thank you. Amen, people. I'll see you next week. This week. Tired already. Hey, thanks, Isaac. Bye. Okay, anyone got any questions? Can you show the QR code for the notes? What notes? What notes you talking about? Hey, bye guys. Take care. Bye. If you are online attendee, cannot. Yeah, no choice. Sorry. Yes, Sanjan.
Yeah, like in real life for the next aim.
Yours is online,
Yeah, because the thing is, right, my laptop kind of broke down. It's like with the repair center now at school. Yeah, then my phone look at this. Yeah, so I cannot really see anything.
Wait Then what about them Both of you Okay, my problem is right. PDF version of the paper. Oh, okay. Let me go back to this. Okay, can?
I think I'm Jahil.
You never know, man. Okay, as much as I want to, right, I can't. Because if everybody were to tell me they want to come down, right, then if the class is full, it's not fair for those who come down. I think that's the logical explanation. But you cannot attend online, is it? If I let you come in, then let them come also.
No, she's already coming.
That's you, Hey, thank you. Okay, but let me end the recording.